Welcome to our Ecology and Ecosystem Dynamics Part 1 session. My name is Daniel Palacios. I am with the Marine Mammal Institute at Oregon State University. And it is my distinct privilege to, I did something already. Oh dear. Now you don't get to see that beautiful slide that I'm sure Peter took a lot of time to prepare. It is my distinct privilege to moderate this session this morning. And yeah, I actually have one of those dog ate my homework stories that I have to admit. I was preparing a beautiful slide presentation for this introduction, and I spilled my tea on my laptop, and hence you don't get to see anything. So hopefully we'll get it sorted out this evening. I have an appointment at the computer store. We'll see how that goes. Fingers crossed. But here we are. I wanted to thank Dee Allen, Dennis Heinemann, Lori Leach, and Jackie Schaff for a fantastic group of presenters we have this morning. And they really did all the work in selecting our presenters. I have a few housekeeping notes here. And yeah, instead of seeing slides, I'm just trying to read my chicken scratch here. So let's see how that goes. But we start from 9 to noon is our session. And from 9 to 10:20, we have 5 talks, each 15 minutes. And then we have a break. And then at 10:45, we have our panel. And we have additional panelists for having some additional perspectives there. And I will ask that we hold our questions to the presenters until the end of our first block of presentations, just to facilitate dynamic logistics here. Let's see. So one additional housekeeping note is that we have a cross-cutting theme between today's morning session and tomorrow's morning session. You will see that we have presentation by Dr. Clarissa Anderson, which is pre-recorded. She's actually not here, on the Southern California Coastal Ocean Observing System in relation to marine mammal health. And in addition to that, we have Carl Goldman from the US International Ocean Observing System Program to give us a high-level perspective of how we can improve collaborations, data sharing, and so forth. So some of the themes that we'll be addressing today will be more related to shifting distributions and ecology. And tomorrow we'll revisit those topics, but from the perspective of marine mammal health. And I think I probably should shut up now and introduce our first speaker. Again, we have 15-minute presentations, and the speakers will have a clock up there where you can see your time. And let's kick this off. So our first presenter, by the way, yeah, this was the other housekeeping note that I had, is we had a last-minute cancellation. Dr. Erin Mayer Goodbroad is not able to be here, but Sean Hayes kindly accepted to give the presentation on North Atlantic right whales. So Sean, if you are somewhere here, oh, there you are.
No worries, we're just going to represent different presentation. Thanks everyone for having me. As he said, I'm not Aaron. I'll do my best to fill in. I Aaron sent me a slide deck of about 50 slides, and then I asked Dan Pendleton, who's now with us as well, to send some slides, and I got some from Carolyn Good. So I'll try and get through all of that in 15 minutes. Luckily, if there's one lesson I got from graduate school as a Costa student, was don't worry about classes, spend your time in the field and write your talk on the plane. So So moving forward on that. So obviously we're here talking about this, and the World Meteorological Organization concluded that we're actually probably likely to hit the 1.5 C tipping point within the next 5 years, not 2030, not 2050. So, so that is an increasing pressure that rides on us. And I've sort of gone through this year in a period of kind of depression and funk about this and thinking a lot about what to do. And range distribution isn't a surprise anymore. It's a fact. This is work that Deb Palka's team in our lab at Northeast Center has been doing, and basically a review of 16 species from our AMAP surveys in the Northeast. And this is with Lance too, I should say, he's in here. So it's Northeast and Southeast surveys. They're all basically moving north, and we had in 7 years a range shift of almost 200 kilometers on average for species. So and then we have the North Atlantic right whale, which is the focus of this talk, and this is getting into Aaron's slides. And what's on the map on the right is kind of what we thought of as sort of the world of North Atlantic right whales and the historical range that they had. But that changed drastically in 2010 when the Gulf of Maine, well, everything was warming. The Gulf of Maine took an aberration and just started to spike, outpacing a lot of the climate warming around the planet. To the point where now the Gulf of Maine is rated as somewhere in the 98th, 99th percent of the hottest warming or fastest warming bodies in the ocean. And so what that meant for us with North Atlantic right whales, this is our detection probability analysis on an annual basis as you're moving through it. So you can see that our survey efforts starting in the 90s had detection probability as the population of, a bad year was 50-some% of a population, and, upwards of 70. And by the time the team was really getting into it in the early 2000s, we were seeing more than 90% of the population. When you think about, this is roughly 400 whales and 400,000 square kilometers of ocean, we're doing pretty good. But then around 2010, that detection rate really took a dump and went down, and we lost them for a while. By and large, we didn't know where many of them were. And then it's climbed back up as we've adapted our surveys. So what happened with that? Well, we don't actually, despite all the resources people think NOAA has, we're actually quite limited. And the reality is what we do is we strategically park cameras outside the most likely places to be. So you can think of it as basically, we watch the coffee shops and the liquor stores and the grocery stores. And we basically, if you just poise a camera in front of those areas, sooner or later, you're going to see the majority of the population. We don't really have significant broad scale coverage. And then when they stop showing up at those places, you have to scratch your head about what is the phenomena that's driving that. It could be it's not cool anymore. There's a double pun there if you're going to catch it thinking about the theme. It could be they're out of resources, or could be people don't like burnt coffee anymore, or there's better resources elsewhere, or there's some new threat or danger in the region that drove them away, just as some ideas. So thinking about right whales, this species, more than a lot of other species, the thing that strikes me about right whales compared to a lot of the things I've worked on is they are one of the ultimate specialists. They don't have a lot of plasticity. They pretty much forage on one tiny little size class of plankton. There's a half dozen species at most in there that really meet their needs. And that's what they do. Even compared to the Balanopteran cousins, they are specialists in many respects. So when you're dependent on this and plankton, so Calanus finmarchicus and a few other species, but we tend to sort of generally refer to Calanus finmarchicus copepods. My wife asked me to put in a plug for the David Attenborough pronunciation, copepods, I think he said. So I promised I would do that. But anything that changes Calanus finmarchicus ability, or the ability of the right whales to harvest them, and that can be a function of just sheer abundance, obviously their number, but then where they're distributed, you have to go looking for them, their density and aggregation. So you can have a lot of them, but if they're dispersed in the water column, that's not really valuable to a right whale. And then energy content. So you basically have an ectothermic critter that is dependent on its metabolism is a function of water temperature. And if it's burning hot, it's burning its oil, which is the lipid content in the bottom, which means the warmer the ocean gets, the less lipid you have in its body. So jumping into Aaron's slides, what happens when Calanus distributions change or availability changes for any one of those mechanisms? And she and and her advisor, Chuck Green, have done a tremendous amount of work over the years, sort of looking at Arctic Ocean circulation and patterns, and basically shown here that when you have changes in the Arctic Ocean oscillation, and I apologize, Aaron, if you're watching and I'm butchering your stuff, but I'm just going to run through this as quick as I can. You basically can find large-scale shifts in Finmarchicus distributions with that. And when you have those large-scale shifts, it can correlate. It seems like it's very likely linked to population growth. And so basically the animal's ability to accumulate resources in those times when those plankton are less available correlates with reproduced in a, blanking on your term, sort of animal that accumulates a lot of resources to get pregnant and have birth. Technical, thank you. If they can't accumulate resources abundantly, then their calving rates are going to go down. And that's what we saw in the 90s. And then Finmarchicus abundance increased, and lo and behold, population rates went up. And they've done a lot of work showing this about how that you can link this sort of ecosystem change to birth rates, but not necessarily death rates. And so I keep jumping back and forth between, I'm going to just try and focus here. So taking a breath, looking at what happened in 2010, we had a very significant regime shift in the Northwest Atlantic, and the Gulf Stream shifted, warm waters arrived. And one of the other things is that gets into this is Calanus abundance declines. And Calanus abundance declines. And one of the subtle things about Calanus in the Gulf of Maine is it's not born there, it's advected there. Its life cycle is not complete within the Gulf of Maine. It has to get advected in from ocean currents. And so when those currents change, you basically stop having the Calanus come in. And then as a result, calving rates decline. And then we saw a distribution shift. We know that the animals moved up to the Gulf of St. Lawrence. And then one of the significant things is, in particularly the more successfully breeding moms, or the moms that were having calves, seems like they were the ones that were going to the Gulf of St. Lawrence. So we have range shift. We're also seeing timing shifts as well. And so this is work that Dan Pendleton and has been doing with colleagues in the southern New England area. And this is in Cape Cod Bay. What you can see is the peak abundance of right whales has shifted by about a day a year for the last 20 years in terms of when they're present in Cape Cod Bay. That's the peak abundance. And this seasonal shift has been changing as well for months. And you basically breaking it down in 2-week periods, it just sort of ticks up and up and up. So these animals are spending more and more time in this particular area. But what's interesting is this is in contrast to the timing of the spring bloom, which is getting earlier and earlier and earlier. So you have this sort of convergence of events where you have more whales showing up and a change in the spring transition date. And it's led Dan and his colleagues to propose the idea that, a lot of right whales showing up in this area may not because it's the most amazing habitat in the world, but it's because they're waiting for something else and habitat to the north to open up. And so they've put forward this idea of a waiting room hypothesis that they converge in Cape Cod Bay and they're just sort of hanging out there. It's the best of poor options available, but so they all show up there and they're sort of staging before they go north somewhere where there likely will be copepods abundant during the summer months. Let's see. And so this gets us to our population trend. And so for 20 years, the population was growing and growing and growing slowly. The agency was managing mortality sources like entanglement and vessel strike and had some successes along the way, but we know we'd never really truly nipped that in the bud or achieved PBR, so to speak. But we got up to almost around roughly 480 animals, and then we had a fairly precipitous decline. And today we're at 356 animals, of which less than 70 of those are likely reproductively active females in this population. So, and that 70 is in our model has a 50% chance of being alive today. So this gets into the births and deaths part of the issue. So looking at deaths first, people tend to, the message I like to think about in this, people tend to focus on the bodies. And I think the bodies are very important for sort of understanding cause. But the statistics we have in a mark and recapture model where you have 95% mark and recapture recovery every single year, it allows you to basically estimate the unseen mortality every single year. And so we've basically been able to take the cryptic mortality, as it's often referred to, and estimate the annual mortality in this population to the precision of just a few, plus or minus a few animals every year. And so what you can see is we saw a lot of dead animals. And in 2017, we talk about like the 17 observed dead whales. The reality is there were upwards of 43 dead whales in 2017. And cumulatively, from 2010 to 21, 50% of the living population died in just over a decade. So this is what can happen when you have a big range shift distribution. Getting into the theme of it. And then the other part of the population equation, births and deaths, turns out they stopped having calves at the same time. And so we're reached the situation where the population demographic was taking it in both directions in the chin, where it was deaths were up, births were down, and obviously the population's in free fall. So why? Obviously ecosystem shifts, but what did that mean? Basically the animals' behavior and distribution changed. They moved into unmanaged areas. There were more encounters between whales and fishing gear and vessels. And as we've mentioned, a part of the other challenge from a prey perspective for this talk is skinny whales just don't have babies when you're a capital breeder. That's the term I'm looking for. Thank you. And so what is NOAA doing about this? Well, for the longest time, and particularly from stakeholder pressure, we've focused on surgical management measures. It's really hard to put management measures on stakeholders. And I think one of the powers of social power of right whales is they cross so many stakeholders that it connects them to society in a way that many of our other great whales don't. I joke that I'm not going to get into that tangent. Maybe it'll come up in the panel discussion. But the long and the short is these animals, we've tried to sort of protect them with small spatial scales. So in just for vessel speed rules. So these are areas where we had vessel speed management along the East Coast in US waters. And it's little bits and places, and one of the big things, we moved the shipping lanes, and that was a really successful management tool coming out of Boston and then, it was followed by a calving boom of like 40 calves a year or two later. So, we have these sort of wins, but we think about this. And now, but with the current population decline, we've realized we have to go a little heavier on this. And so this is what the agency is proposing. So not only are we talking about, we're moving away from the idea of surgical management areas, but broad spatial management areas, which is what we're going to need to be spatially resilient. And we've also done the analysis, and it's the royal we, more like people like Lance in the room and others who've sort of done the analysis to really figure out the size of the vessels that are responsible, both small and large, that we need to be considering. So we're moving forward on this. And then we're also moving forward with different fishing areas. It's really easy to solve the fishing problem with marine mammals. You simply stop fishing, but that's not really a simple thing. But it's a logistically simple solution, but it's a politically impossible one. And so we've tried sort of surgical closures, we've tried different gear solutions, but the reality is we need a solution that you can just do it wherever, anywhere, and it allows for coexistence of the animals and the human activity in the same region. And so that's why we're pushing really hard for ropeless or on-demand technology. So the idea is that, wherever the animals are, if you're fishing with this technology, they should be fairly safe. God knows what consequences are going to come of ropeless fishing technology. But as a colleague of mine once said, the purpose of government is to fix everything you thought you were fixing 30 years ago. And so, which gets to my point is, this range shift isn't a static thing, and this isn't a one and done thing. Right whales are continuing to change their distribution. They're going to keep changing their distribution, and which is my emphasis on why we need spatially resilient management solutions as we're sort of thinking about this moving forward and moving away from surgical local solutions to ones that are large scale and spatially managed. And this is work that Pershing and Pendleton, where they sort of talked about where right whales were in the Gulf of Maine, sort of where they've shifted, the highlight areas in yellow, and where they think that, it might be the next big shift might be if you think in sort of static decades. And then my last slide here is one of circumspect and introspection, I guess. We think about climate change as the issue. But Greenspoon et al. Just put out this paper, and it's a follow-up paper from one of the co-authors about 5 years ago. This is the global biomass of marine mammals and wild terrestrial mammals. You have about 40 million metric tons of marine mammals. The dominant species by biomass is fin whales, if you're curious. For wild terrestrial mammals, it's only 20 million metric tons. Dominant species is actually white-tailed deer. And then you move into us. So I don't know if anyone's seen this statistic before, but the reality is climate change is just a symptom of us and carrying capacity. And so as we're managing them, we often deal with the stakeholders, just stop doing this, stop doing that, right? But there's always the us, and I stand here before you, the son of a livestock farmer and father of 2 children. So I'm contributing both directions to this issue. But I just wanted to conclude as we're sort of thinking, when we think about what solutions are in our toolbox, it's ultimately we have to manage us. And I'll stop there. Thank you.
John, thank you for that very insightful presentation. I hope that you all are keeping notes. There are lots of ideas there in terms of strategies, breeding, feeding strategies. Maybe you're talking about capital breeders. So maybe we'll come back to that in the discussion. I'm here to introduce our next presenter. So we're switching from the North Atlantic to the Bering and Chukchi Sea in the Arctic, and Dr. Kate Stafford is our next presenter.
Probably can.
Okay.
We'll see.
Oh, I see. Yes.
Yes. Thank you. All right, thanks, everybody, and thank you all for the opportunity to come and present to you today. And I suspect the theme is going to be, we don't deserve the planet we live on. So I'm here, as Daniel said, to move us over into the Pacific Arctic and talk about shifting distributions, not just of Arctic species, but also subarctic species. And similar to what Sean was talking about, also talk about human movement into the Arctic and shipping. So I think a lot of you have seen this animation. I think this does a really good job of showing how much both the extent, the age, and the thickness of sea ice has been changing over time. And sea ice really is the driver of Arctic ecosystems. This is a different way to look at it. The average monthly Arctic sea ice extent has been plummeting. And this really matters in places like the Bering Strait. So the Bering Strait is the only gateway between the Pacific and the Arctic. And there is a mass migration twice a year of bowhead whales, beluga whales, bearded seals, walrus. Lots and lots of Arctic species move north through the strait and then south again. We're also seeing major changes in the ecosystem, the physical ecosystem, from the heat, the salinity, and the fresh water that is moving north, and from species like new zooplankton that are being advected into the system. And all of this is resulting in shifting distribution, changes in prey that marine mammals rely on, and potentially increasing threat exposure. One of the fairly interesting elements of the Bering Sea and the Bering Strait region is the formation of the Bering Sea cold pool. And this is an area of about 30 meters depth of cold water that persists primarily in the northern Bering Sea, and it's driven by the extent, the melting, and the reformation of sea ice. And this cold pool has been thought for a long time to represent a thermal barrier between the movement of many, both fish like pollock, but also zooplankton prey into Bering Sea, into the Bering Strait, and into the Arctic. And as of about 2018, the cold pool has disappeared. Now, my understanding from recent data is that it did start to reform this year, but effectively this cold barrier that acted as a physical barrier to species moving north through the Bering Strait has disappeared. Now, we know that marine biodiversity throughout the Arctic is increasing at all trophic levels, from zooplankton to mesopredators and to our top predators. But the Arctic isn't changing equally everywhere. And in the Bering Sea in particular, in the Chukchi Sea, which is a shallow shelf sea, it's only on the average about 50 meters deep, we're essentially seeing a shift from a benthically dominated ecosystem to a pelagically dominated ecosystem. And Sue Moore has done a tremendous amount of work on this. And effectively, with the earlier retreat of sea ice and less extensive sea ice, instead of having our primary production be the result of ice algae, now we're having not I want to say wild phytoplankton, but water-based, it's all water-based. Water column phytoplankton that's serving to feed water column-based zooplankton. Those zooplankton are staying up in the water column where they're now being exploited by things like humpback whales and fin whales and minke whales. But we've also got changes in the fish and the bird distribution, again, as a result of the lack of the cold pool and more pelagic resources into the Chukchi Sea. So for instance, pollock are now regularly seen in the Chukchi. And in fact, the Russian Federation started a commercial fishery for pollock last year. We're also seeing shifts in seabirds that are pelagic zooplanktivores. When the water's warm in the Bering Sea, seabirds shift north. So if we think about Arctic marine mammals, we're also seeing shifts in the timing, both the phenology and the distribution of Arctic marine mammals. Both belugas and bowhead whales, which are the two cetaceans that we have in the Pacific Arctic, are moving out of the Beaufort and Chukchi Seas later in the year. And in some instances, this shift is roughly a week later per decade. So these animals, Arctic species, are spending more time in the high Arctic. And in some instances, and this is work that's been done by Angela Szorka, it certainly looks like bowhead whales in particular, some portion of the population is no longer moving south of Bering Strait. They're spending the entire year either in the Chukchi or the Beaufort Seas. And this is directly related to decreases in sea ice. Now, we care about things like this, not only because we've got changes in phenology, but because people south of Bering Strait, people on St. Lawrence Island, rely on bowhead whales. They rely on walrus. And there's the potential, although it is not happening yet, and people are very adaptable, that there could be fewer food resources and less food security. Oh, I'm just flying through this. It's great. So it's not just acoustic data, and I would say that this slide is largely based on the acoustic detections of bowhead whales and beluga whales. But satellite telemetry data is also showing that bowhead whales are changing their distribution and spending more time further north. And I'm going to focus a little bit on this Bering Strait region. And if you look at the distribution of bowhead whales to the west of St. Lawrence Island in Anadyr Strait, this is critical habitat for these species. It's also critical habitat for walrus and belugas. And we care about this because this is also an area that I'll talk about in just a couple slides. That is where most of the increases in shipping are occurring. So we're seeing that our Arctic species are changing the timing of their migration. They're spending more time in the high Arctic. But what we're also seeing are increases in subarctic species. So they're moving north, further north and staying there longer. One of the big examples is killer whales. So killer whales have been seen increasingly by coastal residents. They've been heard increasingly on acoustic recorders. And recent studies, in fact, have found that we've heard killer whales even up to the Chukchi Plateau, which is at about 75 degrees north. Just this year, killer whales were reported by local hunters as chasing belugas. There were 10 to 15 killer whales offshore of Utqiagvik in October, And so the hunters decided not to go out that day because there were too many killer whales. And finally, there were actually a number of reports off Prudhoe Bay of killer whales, including one that basically sucked down a mom and 2 polar bear cubs. So these whales are moving north. We'll see what happens. And these are just 3 animals that stranded up off of Utqiagvik: a humpback whale that just happened a couple weeks ago, a fin whale that showed up last year, and earlier this year, a young bowhead whale. And the bowhead had certainly been depredated by killer whales. The humpback whale, it wasn't clear. And the fin whale, I think Rafaela thought might have been a ship strike, but that's not clear either. Regardless, we're seeing all these species, barring the bowhead, spending more time in the north and being heard and seen further north and further to the east. Likewise, humpback whales are essentially becoming summertime resident off of the North Slope and in the Beaufort Sea. They're being seen, they're being heard. And at one point when I was studying bowhead whales and humpback whales and thinking about the overlap between these 2 species, I thought they might overlap in space, but they're not going to overlap in space and time. But increasingly, we're now seeing humpback whales, including mums with calves, feeding on prey off of Utqiagvik in September, late August, and potentially even into October. So now these 2 species are overlapping in both space and time. We're also seeing fin whales and minke whales, particularly in the southern Chukchi Sea, particularly off of Point Hope, off of Tikigaq. Sue has been an observer on a number of cruises recently, and she's reported often as many as 50 humpback whales in small feeding aggregations mixed up with gray whales and fin whales. So it's very clear that in the southern Chukchi Sea, certainly, there is a big shift in distribution as well as abundance of these subarctic species. Now, subarctic species have always occurred and been seen in the Arctic, but it tended to be over relatively limited space and time. Now they're there even as late as October and potentially November. And so the overlap of these novel species, subarctic species, certainly potentially presents a threat in terms of a new predator. It also potentially presents a threat in terms of overlap of potential competition for food, because we know, for instance, that bowhead whales are feeding on, primarily they feed on copepods over in the Amundsen Gulf, but when they get to Utqiagvik, they shift to krill. And we suspect that the humpback whales that we've seen at Utqiagvik are eating either krill or potentially eating small schooling fish. But probably one of the biggest threats to all of these species is the increase in shipping. Human use of the Arctic is clearly increasing. The blue line is the Northern Sea Route, and this is the sea route that is used most extensively. This is the sea route that basically links the links the Atlantic to the Pacific. Eventually, probably not too far in the future, we will get the transpolar route, which will be a much shorter stop between the 2 oceans. So we got to get our plastic stuff from one to the other faster, although it is primarily oil and gas that is going across the Northern Sea Route. But it is effectively worth noting that it's a 50% distance savings to go along the Northern Sea Route than it does to go through the Suez Canal. And I don't know how many of you remember that last year, there was that ship that actually went side 2 in the Suez Canal and blocked it for weeks. I was just listening to NPR last week, and apparently the Panama Canal is essentially out of water. So they're going to be greatly restricting shipping through the Panama Canal, which suggests that more and more ships are going to be going up through the Arctic. I mean, effectively, ship traffic has almost doubled, and this is in the summer. What worries me a little bit is that ship traffic is also increasing in the winter. Now, we're not talking the number of ships that go in and out of the Port of Los Angeles or in and out of Boston. But every year now, in December and January and February, 4 to 8 ships are going right through Anadir Strait. They're going through the sea ice. It's dark. You can't see anything. And this is critical habitat, again, for walrus, for bowhead whales, for beluga whales, and for bearded seals. So this, I think, is our biggest conservation issue beyond broader climate change and sea ice melt that we have to deal with in the Bering Strait and the Chukchi Sea region. So we know that the Pacific Arctic is changing, and it's changing really rapidly, both from the heat content of the water, the saltiness or lack of saltiness of the water, and changes in distribution of species. And so what does this mean? It means potentially we're going to be dealing with interspecific competition for Arctic marine mammals versus subarctic marine mammals. We've got increased potential predation, the possibility of ship strikes, and certainly potentially fishing entanglement as fishing moves further north. Currently, there is not supposed to be any commercial fisheries in the Pacific Arctic, but I suspect that's changing, especially as species like Opelio, snow crab, are moving north. To go back to sort of Sean's ending words, you know, we are an insatiable species. So let me think of something positive to end on. So the only positive, one of the positive things I think is both the people of the Arctic are incredibly adaptable, and they're used to change and they will adapt to change. As we change the biodiversity of the Arctic, you know, Sean mentioned, and we'll hear later about all these species moving north, there's only so much further you can go. Our bowhead whales, the Western Arctic population of bowhead whales is growing, it's healthy. Unlike North Atlantic right whales, it turns out if you stop killing whales and you don't run over them and you don't put a lot of lines in the water, they will recover. So that's also a good story to celebrate. We need to celebrate that conservation success story. So with that, I will stop talking and thank you very much for your attention.
Thank you, Kate. I wanted to highlight, because I know you've done a bit of this work, Kate, in terms of working with the local communities and indigenous communities, that part of the effort to document these shifts in distributions and so forth should take more into consideration the local coastal communities and so forth. Our next presenter is Fernando Elorriaga, and we're shifting to more subtropical temperate latitudes and also to the pinnipeds with a talk on Guadalupe fur seals. This one. Thank you, Fernando.
Thank you. Hi, everyone. Good morning. It's a privilege to be here. Thank you. Thanks a lot for the invitation. So I'm here. I was given the opportunity to speak about these other species. We are going to see a slightly different type of story with this fur seal. This is pinniped species from the Baja California Peninsula, and its relationship with climate variability and how it has impacted its current recovery. First of all, let me tell you that this fur seal species was almost close to extinction at the end of the 19th century because of overhunting. Due to the value of its fur, they almost took it to extinction, especially by Russian hunters and from other parts of the world. In those eras, before overexploitation in the 18th, 19th century, we were talking about a much wider distribution. This was the original distribution of the Guadalupe fur seal. You can see a much better representation in the northeastern Pacific, yielding a population, overall population size of around 200,000 individuals. Nowadays, it is different. This is a different distribution. Here you can see how it is distributed now, especially in Guadalupe Island. You can see well, you cannot see my laser, but yeah. You can see the relationship between the color and the type of site we are talking about. The only well-established breeding site on Guadalupe Island, a recolonization site at the San Benito Archipelago. This site is very important. It was recolonized at the end of the 90s. It has an occasional presence on the Channel Islands in California, and is currently developing a colonization progress for the first time. This is unprecedented, a colonization into the Gulf of California. You can see the different logos. These are the different natural protected areas that fortunately are related to the current Guadalupe fur seal distribution. So how it is classified in terms of conservation? You can make your pick here based on the red list as least concerned, endangered by Mexican law, threatened by the Endangered Species Act, and depleted by the Marine Mammal Protection Act. And of course, you can think of depleted if you see how at the beginning of the 20th century, it was almost gone. It was rediscovered in the 50s with what it was described as 14 animals. This is could be a little bit doubtful, but they were really few individuals on Guadalupe Island. And nowadays, based on our last surveys trying to calculate the overall population size, we would be talking about 86,000 individuals across its distribution. But again, keep this in mind. Guadalupe Island keeps being the only well-established breeding site. The only ones are non-reproductive colonies. So these are some of our surveys in the last years trying to estimate the global population size of the Guadalupe fur seal. You can see slightly similar numbers. This is the most recent one. And I put the logo of the Marine Mammal Commission here because they were so important regarding financial support. And we appreciate that a lot. So this is our latest estimation. And this is part of this strong recovery of the fur seal. This is a work by Ariadna Juarez-Ruiz, part of her PhD. She published this eventually. And this is the production, the production of Guadalupe fur seals. And here is where we go into the climate or the variability of the environment. How is it affecting? You can see a type of curve that it's typical of this species on the recovery. However, you can see declines in pup production, not due to this kind of anomalies of sea surface temperatures, these warming events, not so much those, but these ones here, what we consider the most extreme warming events, like the ones that took place in between 2014, 2015. So even though the species is on the recovery, climate is affecting its recovery. This is, of course, shaking hands with other studies made by Cassandra Galvez. She made this is part of her master's and her PhD studies with us too. And here, basically, you can see if we could make a small zoom in to the last curve, you can see in between 13 and 16 these years, how there has been a relationship in between weights of neonates, Guadalupe fur seals, and sea surface temperatures. So what Cassandra found, basically in a nutshell, is the lowest weights during the most extreme sea surface temperature anomalies. This was 2014 and 2015, at pretty much a relationship in between a decrease of 1.7 kilograms for each increase of 1 degree. So that's a lot if you consider that neonates have a weight of about 6 kilograms. So 1.7 kilograms is a lot. And Cassandra also found an increased mortality due to emaciation during the 2015 breeding season. So this is very important for the recovery of the Guadalupe fur seal, that where the only breeding site, as I said, is Guadalupe Island. Now we go a little bit south into the San Benito Archipelago. This is a Guadalupe fur seal expansion site. It is non-reproductive. You see all these juveniles are not having pups during the summer, which is the breeding season. And what do we see in this expansion site? Here you can see our surveys, especially from 2012 on. And you can see a very good trend. Once again, thank you, Marine Mammal Commission, for these 2 last years were really, really important for us. Look at these high numbers in this expansion side. It has increased, but I would like you to see this, how there was a really strong decline from 2014 to 15 during El Nino and the heat wave from the North Pacific called the Bluff. Many of you have heard about the Bluff, and how it took a while in order to recover after El Nino. And this is a very important expansion site, because after Guadalupe, it could be the next breeding site based on what we have found on these islands in the Pacific of Baja California. And also, as a complementary result of this reduced abundance, this absence of fur seals during El Nino, we saw this kind of results based on stable isotopes. I'm not going to get too much into it, but believe me that the larger the foraging ground you are feeding on, the larger the possibility you are going to be absorbing different isotopic sources. So take a look at the 2015 isotopic niche, which could be the result of an increase of the cover the fur seals were using in order to feed, about 3 times larger. And this goes, or this is coherent with what has been described for pinnipeds during warm anomalies, where they increase their foraging effort and the energetic demands that it implies. And regarding habitat use, the Guadalupe fur seal is remarkable. So it is dealing with climate variability. It has its obstacles. This is one of our main projects right now that's related to telemetry, satellite tagging. This project is in collaboration also with Tenaya Norris, one of our most valuable, significant collaborators from the Marine Mammal Center. This is also part of Maria Jose Amador, a student of us, a PhD student, who is also being supported by Roxanne Beltran, a specialist in telemetry of pinnipeds from the University of California. How do you look, take a look at this. This is Guadalupe Island, where these animals were attacked. They are able, even adult females, are able to move to really, really long distances. These are years from 2017 to 2020. And this large dispersal capacity, not only north, but also south into the mouth of the Gulf of California, take a look at this, has enabled these species to reach the Gulf of California. This is unprecedented, but again, it's full of these kind of individuals, juveniles. These are non-reproductive sites, in sites like these Las Animas, that in English is like the spirits or the ghosts, Las Animas, composed by these kind of individuals. That it is also increasing a lot. This is part of the bachelor thesis of Luis Estrada, a student of ours. And here you can see the large increase. And of course, we are very interested in knowing how current Niño conditions could affect the establishment of this colony. So El Niño, the warming events, all these processes that deplete resources for these top predators. And this factor is very important for the Guadalupe fur seal recovery. It has been established in the past as the main factor rather than others. So in this regard, let me come back to the mother colony, Guadalupe Island. What does the Guadalupe fur seal feed on? This is basically Teutophagous species. Again, these are works by Ariadna Juarez and Majo Amador from their thesis with us, with their master's studies. So you can see it is basically squids, but especially the jumbo squid. And please see this here, this is recent foraging habits. And this is very important because in the past, before 2013, the jumbo squid was not part of the diet of the Guadalupe fur seal, or it was non-significant based on all the references. This is also related to climate change, how the population of Dosidicus gigas, the jumbo squid, has increased in a very significant manner in the North Pacific, in the California current system, And the Guadalupe fur seal seems to have taken advantage of the expansion of this squid. In this regard, a MAHO analysis for her masters based on stable isotopes. Once again, I'm not going to get too much into it, but see the 2015 and 16 years related to these events, these variations that if we couple these variations with what we know about inshore, offshore habitat use or latitudinal variations, we would be having something like this. This is the telemetry information from 2017 to 2020. Unfortunately, we don't have telemetry data for El Niño, but based on MAHO information, stable isotopes could be telling us that animals during these years were feeding further offshore and further north. And at the same time, MAHO found that the jumbo squid kept always being a dominant part of the diet of these species, but the neon flying squid was really showing up during these years. So we are speaking about a teutophagous species, the Guadalupe fur seal, that under extreme warming scenarios modifies its habitat use and also prey composition. So this could have ecological implications regarding its recovery. And of course, when we talk about these years, many of you may be familiar with this kind of phenomena that took place a few years back. An UME of Guadalupe fur seals from 2015 to 2021, both in California and also in Oregon and Washington. These events were related to about 700 animals that stranded during emaciated conditions, especially young individuals, and it was all related to these kind of events. And very interestingly, this is not the first UME that has been recorded for the Guadalupe fur seal. There was another that was described by Agnes and collaborators in 2020, in between 2006 and 2012, also related to emaciated individuals. So as a conclusion, we can say, yes, this is a nice positive story where there is a recovery. Here is the growth rate until 2019, but we cannot lose sight of this, what I've been telling you over and over, and the fact that in presence of extreme warm anomalies, what happens? There is a decline in pop production within this recovery process. There is a decline in abundance in sites like San Benito. There are shifts in foraging grounds or increasing their foraging cover, as well as variation in prey composition. There is a decrease in body mass and an increase in their mortality, talking about neonates of these species. And finally, there is also this type of events that are very important related to the UMEs and emaciated individuals. So we can say it is under recovery. The Guadalupe fur seal is under recovery, and it's also a monitor of climate change in the Northeastern Pacific. So that would be all. I only would like to thank these institutional authorities that have been really related to our work. And of course, a lot of students of our group, because without them, we would not be able to do a lot. So thank to everyone, to all of these guys. Thank you. Thank you.
Thank you to Dr. Elorriaga Verplanken for this wonderful presentation. It's added to what we've been discussing this morning, the dimension of disruptive events in addition to climate change. There's also these marine heat waves and all the things that are more familiar to us, like El Nino events and such things that basically make the environmental scenario more complicated. Our next presentation is on humpback whales, and for that presentation we have Dr. Karim Forney. And let me get your presentation up and running here. Yes. Good.
Great, thank you. Sorry, short people, mic adjustment. Yeah, thanks. It's so great to be here. Thank you to the commission for bringing me on board, and I'm excited to be talking to you, telling a little bit of the story, staying in the California current system, a little bit of the story at a high level about the humpback whale entanglements that have increased on the West Coast, what we know about that, the causes related to shifting prey and whale distributions, as well as fishery distributions, what management actions have been taken across the 3 West Coast states involved, and some of the scientific studies that have been evaluating how successful can we be at mitigating this issue. So a quick primer on very messy, complicated humpback whales in the Pacific. The whales that forage off California and Oregon and Washington are primarily from the 2 distinct population segments that breed in Central America and Mexico. The top left panel shows the complex migration patterns between breeding and feeding areas. The lower panel shows a population trend graph through 2018, showing that the population has been recovering post-commercial whaling. We have identified over many years, John Calambakidis has been instrumental in this, biologically important areas, the foraging areas, and I primarily want to draw your attention to the areas in red along the coastline, in particular Central California, in Oregon and Washington, and note that compared to the scales we've been looking at in the Atlantic and in the Arctic and everywhere, this is a very narrow shelf region. I mean, we're talking tens of kilometers wide in the widest locations. And in that region, whales forage on krill, on the shelf break, and on schooling fish in the shelf waters. So our big shock, we were always happy that the whales would leave away in the winter, go away in the winter and go south, and the fisheries that were in nearshore waters were all in the wintertime, and so there was no temporal overlap between those. But suddenly, beginning in 2014, where the red arrow is, we started seeing a dramatic increase in humpback whale entanglements on the West Coast. And we were very concerned, very alarmed. The numbers were quite a bit higher than the PBR, and we really didn't understand what was going on. So the first thing was to look at the origin of these entanglements. And the pie chart on the left, the colors, sorry, they're a little confusing because they match the bar charts, but they don't relate to one another. The green on the pie chart shows unidentified fisheries. So we have a lot of fisheries, line fisheries, net that we just weren't able to identify. You just see a whale entangled in rope. But the blue segment on the pie chart is the Dungeness crab fishery. So that is the fishery that had the largest proportion of identified entanglements. And then there's a whole suite of others, spot prawn fishery, black cod, some gillnets, and other fisheries. But really the Dungeness crab fishery was identified as the primary entangling fishery. And on the right side is just an example of, for like the fourth quarter from Lauren Seiss's work looking at the distribution. And what I want to have you note there is also this is a very narrow shelf distribution for this fishery. And if you look at the Central California and Oregon and Washington areas in red, where the greatest amount of fishing effort is, those are precisely the areas that are key foraging grounds for humpback whales. So what happened? This is a very complex slide, busy slide. Jared Santoral led an amazing team of climate scientists and fishery and marine mammal ecologists to really try to get to the bottom of what happened during this event. It happened to coincide with the marine heat wave that's already been mentioned, the blob. And Jared and colleagues were able, and I'm also a co-author on that, but we're able to narrow it down to a complex interaction, a perfect storm, if you will, of changes in ocean conditions shown in red. We had the marine heat wave and a pretty dramatic compression of cool water near the coast to within really just a few kilometers of the coast was all the cool water, which is where the productivity tends to happen in this environment. That led to a number of prey changes near shore in the green box, such that krill was completely absent. There was no suitable habitat for krill, similar to what we heard about the copepods. In the Atlantic, they like the cooler water, and the anchovies, which actually weren't abundant, but they became highly compressed near shore again within 1 to 2 kilometers of shore. What that meant is that all of the humpback whales that were foraging on the coastline were confined to these extremely narrow areas near shore and feeding, and they also ended up not leaving. A large number of them did not leave the coast for their southbound migration, and they stayed there for the entire winter, overlapping to a great extent with the fishery. Exacerbating things was that the fishery was also struggling at that time with a lot of domoic acid. This is a toxic algal bloom that impacts a number of species. Francis has done a lot of work on pinnipeds and other species, seabirds, but most particularly the crab fishery, that the crab fishery were delayed into the springtime because of the large presence of domoic acid in the crabs. So that meant that not only were the whales there throughout the entire winter, overlapping with the peak fishing season in the normal years, but during the domoic acid years of 2015 and 2016, most of the fishing effort was in the springtime when the entire population, including those animals that went to the breeding grounds, came back. So really tremendous change in the overlap between the fisheries and the whales. So what was done about it? I want to quickly run through each state, give you a sense of how the states reacted. They were all a little bit different. There is a tri-state management for crab, but this issue was dealt with slightly differently in each state. All the three states going to this immediately brought a team together and started looking at best practices, reducing the surface slack in line. How can we, avoid whale entanglement at whale areas and setting gear? And they also began supporting alternative gear development, such as the ropeless or on-demand gear we've already heard about. They increased their derelict gear removal program. About 10% of pots are lost each year, and many of those continue to actively fish and can risk entanglement. And they also, with that, did some recreational crab fishery regulations and initiated the process of developing a conservation plan for incidental take authorizations. Most significantly, California implemented a very complex, dynamic type of management for the fishery. The goal is to allow the fishery to fish for the greatest length of the season, but not allow them to start until the sufficient whales were gone. There were few enough whales. And once the whales started arriving in the spring, then to have the gear pulled out early. And so this involved a complex series of biweekly evaluations where we looked at all available data, opportunistic targeted aerial surveys, some of which I was involved in and led, ecosystem changes. How compressed is the habitat, since that relates to the amount of whales within that narrow nearshore band? Fishery dynamics, are they delayed by crab quality or domoic acid? And really putting it all together in a multi-stakeholder working group that then made recommendations to the California Department of Fish and Wildlife director, who ultimately would make a decision about opening. And this is done every 2 weeks before the season and then during the season, and then particularly at the tail end of the season. So it's a very data and time intensive process, but the intent is to maximize the amount of fishing while reducing the exposure of entanglement to whales. And it's done on a zonal basis. I've got those zones showed there. Oregon had a much simpler approach. They also developed a best practice guide, but they just said, okay, the issue is primarily in the springtime there. When the whales are coming back, we need to reduce the amount of gear in the springtime. So they effectively, they implemented a 25% reduction in gear and said you cannot fish inside of 40 fathoms. You have to fish inside of 40 fathoms. So depth restriction. They also subsequently implemented restrictions in the amount of surface gear. So really trying to tighten up a lot of there are occurrences where fishermen are moving traps around and they have much longer line than they really need at a given depth. They develop their gear for a deeper location and then move it to a shallower location. And often you'll get tens or even hundreds of feet of extra slack that ends up potentially entangling. So they issued regulations. And then they also changed their regulations to allow retention of any crabs that are found in derelict gear to encourage the trap removal of lost gear. And similarly, they developed a conservation plan that was developed in 2021 with the key elements, that we would expect of reducing the co-occurrence with whales and other ESA listed species, reducing the amount of vertical lines, and supporting alternate gear development. The Washington basically had a similar strategy without the depth restriction. They also had data showing that the entanglements were mostly in the spring, so they implemented a flat 33% reduction in the springtime. and also are issued regulations that are to encourage line marking so that the fisheries involved can be more readily identified. And then working on a draft conservation plan that includes some static measures, these static measures, but also has a section on adaptive management if those static measures are not sufficient. So what I want to briefly touch on, see if I can get through this. A few studies, very high level. I'll just show some key graphics, but the papers are indicated for anyone interested in evaluating how likely are these management measures to succeed. So the first question is, where is the fishing taking place? And there's not good information on the distribution. And so Blake Feist led an effort using VMS data and landings data to assess the distribution of fishing effort. And the two things I'd like to note here is that in the lower left panel, you can see a seasonal pattern in the fishing effort. And that black line is during the marine heat wave. And you can see that with the domoic acid closure, that shifted all of the effort into the springtime when there were much greater numbers of whales present. This graphic is a little bit busy and makes you wonder whether you had too much to drink sometimes when I look at it. But it shows there's 3 in a row trimesters of the year from 2011 to 2016. And it just shows, if you look, for instance, at Central California, the variability in the distribution of effort across years. And so this formed a layer for some of the evaluations that were in the subsequent studies I'll be talking about. The second piece is a humpback whale density model that I developed, and to try to be able to model and say how could different measures have worked. Our existing models are not temporally resolved year round. And so I developed a very fine scale model that actually the animation is showing that captured the seasonal migration and the changes in key foraging grounds quite nicely. And the one thing we were excited about with this model is the lower panel, which is really busy. Each line is a different region along the coast. And on the left part, you can see that there's a seasonal migration with the dips in density that is pretty broad scale. But then during the marine heat wave, basically all hell broke loose. And it showed, the model captured that the whales remained in the area during that time. And so we were happy with that. So this model formed the basis for a couple of other studies. Whoops, what happened here? Can we go on? I seem to be stuck. Try the button. There. Okay. So Jamil Samori at the Northwest Fisheries Science Center led the initial effort combining that Feist model and with the Feist fishing data and my model, and looking at a range of management options. And the rights panel shows, broken down by 3 different periods. The blue values are the non-marine heat wave. The red values are the heat wave. And basically what we can see, the x-axis shows different potential mitigation measures. And the y-axis on the top shows the reduction in risk. And so we can see that during the marine heat wave, even the most extreme measures didn't reduce the risk very much. And despite the fact that there was a cost to the fishery shown in the lower bottom panel. But the best option was to delay the start and to close early in the spring, which kind of makes sense with the seasonal migration. Similarly, off Washington State had implemented the springtime gear reduction, 33% gear reduction. And Lina Ricula led a study that also used the whale model to examine the success of that. It was in 2019 and 2020. And so she used the layer of the average fishery footprint, as well as the dynamic humpback whale model to look at overlap between those and how much risk would have been accomplished during 2019 and 2020. And in both years, it did reduce the risk quite substantially, shown on the right, those negative bars, as much as 80%. But what was interesting in the study is that in 2019, it was primarily because the whales moved out of the fishing area, versus in 2020, it was because of the gear reduction. And this really emphasizes that these measures are not going to be equally effective in every year. There's a lot of variability. The last study I wanted to mention was recently published. Chris Free at UC Santa Barbara led that effort, and he also used that same humpback whale model along with a simulation fishing effort based on where the landing blocks were, looking at a distribution of crab and the fishing effort, and then simulated using a sort of random walk fishing gear and whale encounters based on that. So it was a slightly different analysis approach. And he also looked at this right panel is very busy, and I'm not going to be able to go through it in detail, but please take a look at the paper if you're interested. The key is, though, that the red management measures up there are static. The green ones are reactive. So if you have entanglements, you shut things down. And the blue ones are proactive in that you go out and you do assessments and find out whether there are whales there, and then you react. So these are different types of management measures. And I'll just, the key take home message was that you could get 30 to 50% gear reductions resulted in, based on the static measures. And that resulted in 80 to 90% of the overall crab catch in his model. The dynamic options, the reactive and proactive measures, were less effective and often came at a much greater cost to the fishery. So the take-home message of the study was, interestingly, that despite the extremely dynamic nature of this system and of the problem, a static measure that really sort of lopped off the two biggest, the low-hanging fruit, seemed to be the most effective. But this is all ongoing work. And I want to emphasize these are all just studies making assumptions that are food for thought. None of this is really giving us the true answer. So no silver bullet there. So just in summary, the spatial and temporal shifts of prey and humpback whales, and actually over very small spatial scales compared to some of the other studies we've had, led to a major change in entanglement risk. And the marine heat wave of 2014 to 16 was really the main driver. But even following the heat wave, levels have remained elevated for a number of different reasons. And one of that is probably that the population continues to grow and expand into new habitats. The different regulations implemented by the 3 states on the West Coast were a combination of static and dynamic management measures, and they're all working actively on the conservation plans. And these measures, a lot of the measures have been evaluated, but there really isn't a silver bullet that's going to be able to fix this, not surprisingly. And that this, will continue to be challenging as we look at this dynamic system, these small spatial scales, changing climate that will change the nature of these, and the increasing whale populations and pressure on the fishermen. So it's been an interesting challenge to work on, and it's been an interesting challenge. So I'm over a time, sorry about that, but thank you very much. And I also wanted to thank Dan Lawson and Lauren Seiss for some slide materials from the management of the house, and thank the commission. Thank you.
Thank you, Karen Forney. And I wanted to highlight from this last presentation, the previous one, how, as I was saying earlier, these other patterns of climate change and climate variability that may be part of the natural system, but are probably being exacerbated by climate change, also result in things like UMEs in the case of the Guadalupe fur seals, and the rise in entanglement, and a very complex, triggering a very complex management problem for the agencies. So we have one more presentation, and this is pre-recorded, as I mentioned earlier, by Dr. Clarissa Anderson. And it's going to be on harmful algal blooms. I think I'm going to need some assistance with oh, excellent. Thank you. Okay, so I better get out of the way. Thank you.
Good morning. Actually, it's good afternoon here in Kyoto. I'm in Kyoto, Japan, and I'm Clarissa Anderson, Director of SCOOS, the Southern California Coastal Ocean Observing System. We're one of the regional associations of IUS. I'm now also the Director of CMES, which is the NOAA Cooperative Institute at Scripps. Really, thank you for inviting me, and I'm sorry that this is a pre-recorded talk. I'm also want to apologize because I'm a bit under the weather, but I will do my best, and I'll miss having lively discussions with all of you there in person. So given the short time frame, let me dive right in. I'd like to cover quite a bit of ground. So first I want to describe to you the marine mammal mortality event of 2023, and this was preceded by a dress rehearsal of sorts in 2022. Then I'm going to go into more of a higher level discussion of IUS involvement in the marine mammal tracking arena. As I describe a lot of our response, particularly this year and last year, to the marine mammal mortality events that occurred, I'll be mentioning components of the HAB early warning system in California, and this has a really long legacy that dates back to the early 2000s, includes things like weekly HAB sampling at shore stations, operational predictions of domoic acid probability, a network of 12 imaging flow cytobots. Those are robotic microscopes at nearshore and offshore moorings, monthly bulletins, and then a lot of R&D on molecular and mechanistic modeling to predict HABs. So keep this in mind as you see data as I move forward. So this last May and early June, the headlines and media inquiries began flooding in as California sea lions and long-beaked dolphins were appearing in large numbers on central to Southern California beaches. As many of you probably know, this quickly became national news. And that was in large part because of the dolphin strandings and the fact that the bloom was ongoing for months, really from late May to July. And there were human interactions with sea lions that led to bites and hospital visits as beachgoers were just flooding the beaches as we went into the 4th of July holiday. It's not clear that we have the whole tally yet for how many animals ultimately were stranded and many euthanized, but the last update revealed over 1,000 suspect California sea lions from DA toxicosis or intoxication, and over 100 long-beaked common dolphins. My brain is high on drugs right now. Over the May to early August period, and that stretched from San Luis Obispo County all the way to San Diego County at the US-Mexico border. Centers were scrambling to build new cages. I think a lot of you probably heard these stories. They were trying to house this incredible influx of animals. Groups like the Marine Mammal Center in LA were working with the city to create beach pens to corral sick animals. It was quite a frenzy and a really large, perhaps record event. The Sea Harm Model system, which is now an operational model at NOAA Coast Watch and is distributed by the California Ocean Observing System portal, our data portal, which is kind of a joint effort between SCOOS and SENCOOS. It predicts the probability of high domoic acid events in this very spatially explicit manner, a lot like a weather forecast. Over the course of the event, it predicted high probabilities for Central to Southern California. You're seeing that here, and seemed to really track the duration of the event pretty well. It's known to align better with strandings of California sea lions and other animals than it is to say nearshore shellfish toxicity or maybe aquaculture data, in part because we're looking at this larger spatial area and animals are foraging over these larger areas and capturing that variability. At the nearshore sites, though, our HabMap sites, we captured bloom levels of the less toxigenic size class of Pseudonychia, but we didn't really get that Seriatus size class. That's the larger size class. Never really got high DA. It never really surpassed those thresholds. Really only once in early June, and that was at Cal Poly Pier. A shellfish advisory was issued, but not until early July, and only for Santa Barbara County. So did the bloom start near shore, move offshore, get recirculated or re-upwelled back to the near shore? We don't really know the answers to all those questions yet. Interestingly, there was a delay in the spiny lobster fishery in Los Angeles and Orange counties, and that was due to high levels of domoic acid, but we never measured much at those sites. The IFCB network was mostly down for maintenance, unfortunately, in Southern California during this bloom. But even those that were operational never really caught much in the way of Pseudonychia. Sorry, trying to advance my slide. But interestingly, we did get some NOAA event response funding, and that was to sample offshore, better capture what's happening in the offshore zone. And during the dress rehearsal of this 2023 event in 2022, August of 2022, we also got event response funding, and the focus there was on Santa Barbara, both blooms, that was the nexus. We had event response funding that got us onto various cruises like Cal Coffee, Blooms and Blooms, in order to do some extra sampling. And what you can see here is that the middle of the channel, Santa Barbara Channel, was loaded with Pseudonychia australis, and the highest domoic acid concentrations shown here were offshore and subsurface, which of course is telling. since that's where these animals seem to generally feed and forage. And they were really acquiring this domoic acid deep, which really leads to the main crux of what we're asking for often in our HAB sampling, is that we need more offshore monitoring. There we go. So I wanted to also show you some of the domoic acid results from both of those years. We have more of the data from 2022, and we've already broken domoic acid records for marine mammal tissue. On the plot on the left, which is from 2022, we saw California sea lion feces coming in over 500,000 nanograms per gram, which we believe is a record. And then this year we do have preliminary results from the dolphin samples showing potential records of getting close to 300,000 nanograms per gram, which is pretty amazing and a little scary when you think about the trajectory that some of these blooms are on in terms of intensity. SCOOS was in constant, almost daily communication with the Marine Mammal Stranding Network during both of these events. And a lot of this was done via email, sometimes in a pretty informal and scattered way. I would say that kind of scattershot communication is something that I would like to be talking with all of you about in this forum, although I'm not there in person. I think we missed a lot of folks at first due to the lack of formalization. We don't have a really good way of handling real-time communication across the network, and to manage information delivery for things like sea harm, the nearshore sampling, the NMFS, or California Department of Fish and Wildlife advisories. We put together this web app, which was very much on the fly in June of this year, that would collate all of this information into one place for routine service delivery. So this is something we need to improve upon so that it's ready and perfected for the next event, God willing. We also have this bulletin. So SCOOS put together this HAB bulletin that we do monthly. We issued this special monthly bulletin this year, focusing on that bloom and the marine mammal strandings. And this is where all the data are compiled and translated for a real general audience, but goes out to anyone on the listserv. And normally this would be monthly, as I said, but we really wanted to condense everything here and all the data that we gathered from the Marine Mammal Stranding Network. So this takes time, and many of the centers still don't have a formal or codified way to make all of their information machine readable. So we may never have all of that information as we'd like, but I think moving forward, that's something we need to focus on, which gets me to this last slide of this section, which is that we put together some of these asks with Tanaya Norris. This is in part put together for a NASA bid, a failed NASA bid, but these are still highly relevant, and they do form the basis for future proposals that we're working on at the moment. We think we need to develop the standardized case definition matrix to classify domoic acid toxicosis or intoxication cases across taxa, and that we need to develop a real-time reporting system that would increase information sharing, data visualization, and allow the Marine Mammal Stranding Network to be better prepared as a bloom unfolds and as animals are moving from north to south or both. I mean, we hypothesize that these events are worsening in intensity based on the frequency of blooms and also the toxin records we're seeing both in the water and in animals. Animal movement in the ocean, of course, can be tracked via satellites and acoustic telemetry, and that helps us better understand shifting signals, helps us understand national variability versus climate change. And so the second section here is really about how we could deal more broadly with animal tracking and how IUCE is working with many, many partners to establish a national network that captures animal movement, the shifting ranges of species and habitats, climate-related shifts, much more. I think this is critical for many use cases related to marine mammals and ecosystem health. And the vision of this animal telemetry network, as you see here, is to provide unity, stability, and continuity such that ATN data are optimally integrated into all ocean observing capabilities and data portals. I think Carl's going to speak on this a bit more in his IUCE overview, but I'm going to touch on just a couple of things here as I wrap up. The data component is a central focus of IUCE with new initiatives like BioTrack, which I'm sure you've heard of, given the IUCE and the Regional Association expertise in data management. Animal-borne data are useful not only for tracking animal movement and physiology, but for filling critical gaps in subsurface ocean data. And we're already doing this, assimilating data into near real-time operational circulation models, things like the West Coast operational forecast system. And this really helps improve accuracy, that sort of, data assimilative approach. And regional nodes are coming online to flesh out national capacity. So one of those regions that has focused specifically on cetaceans is the Gulf of Mexico, with the project with the same name, Cetacean, and that stands for the Compilation of Environmental Threats and Animal Data for Cetacean Population Health Analysis Platform. GCUS, as many of you know, is the IU's Regional Association for the Gulf of Mexico. They are now leading this effort, which has had a multi-year run-up with partners like Axiom Data Science. So this is a 2-year reboot. GCUS will build a data product to guide and track the restoration of open ocean animals in the Gulf. So I think it's going to focus on cetaceans, given the name. They're currently looking to hire a marine mammal biologist and data scientist to support this effort. And I think there's a lot more going on here, but this was the slide that Jorge Brenner provided me, and we can always direct questions to him if we have more questions about cetacean, and everything else we can direct to Carl. Just kidding. I think I'm completely out of time, but I really thank you for this opportunity. I wish I were there to chat more, and I hope that Carl can pick up where I have left off with his presentation. And thank you very much.
So that concludes our first session on presentations, and we are only about 5 minutes behind. I did want to thank all the speakers for their amazing presentations and for staying on time. From that last talk, I just wanted to highlight that what stood out to me is that we now have the tools and the capabilities and predictive and monitoring tools for basically real-time detection of events that are going on. So better capability for responding to disruptive events in near real time or near real time. So we're going to go into a break until 10:45. Is that right? Okay, so we have 20 minutes, and we'll see you back for the panel session. Thank you very much.
Thank you. Thanks, everybody, for a great session. And before you go, I just want to make one brief announcement that there's a large rally that's taking place on the mall, which is 2 blocks that way. And so there will be, when you go out, there may be, I haven't been out, but there may be large crowds sort of moving toward that rally. The facility has decided to be closed to the public today while we have our private event, just because they don't want this massive, people coming in using the restrooms and everything. So the front doors will not be just unlocked for open access. We'll have someone up there to help people come in and out. And as you're outside, I mean, you're going to be, perhaps, I don't know, we'll go outside and see how many people are out there, but seeing large crowds and taking care to behave responsibly.
two people joining us for the panel. One of them is here and is Carl. And we also have Dr. Donna Hauser joining us remotely. And what I'd like to do is to first have Dr. Hauser introduce herself. And while you have the podium there, Donna, I would like to ask if you could maybe make some initial statements about connections, especially with the Arctic and Kate Stafford's presentation. And then we'll have Carl talk a little bit more about his introduction and work with the IUs, and then we'll take it from there. So Donna, if you would start, please.
Yeah, good morning, everybody. I'm Dr. Donna Hauser from the International Arctic Research Center at the University of Alaska Fairbanks. And I'm joining you really early from the homelands of the Lower Tanana Dene people in Fairbanks, Alaska. So I'm a marine ecologist, but particularly have been looking at changes in distribution, habitat, and movements of Arctic marine mammals in Northern Alaska. But I also grew up in Alaska, and so was really honored to come home and work here on the species that are so integral to the ecosystems, like marine mammals, but also they're key components of nutritional, spiritual, cultural ways of life for Alaska Native people. So increasingly, my research has been conducted in partnership with coastal Indigenous Alaskans. I lead a program, a community-based observing program called the Alaska Arctic Observatory and Knowledge Hub. We call it AOK for short. So if I shift into that, that's what I'm talking about. And that Alaska Arctic Observatory and Knowledge Hub works with a network of coastal Inupiat observers to document long-term and holistic observations of environmental change and impacts in Northern Alaska. And just to sort of follow on with your question, understanding and responding to some of the ecosystem and habitat changes that are affecting coastal Indigenous communities, at least in the Alaskan Arctic, could be strengthened by including community-based observations. And so programs like AOK provide this local perspective that might not be available through conventional scientific methods alone. And so hopefully, or I think it could be used to fill some of the existing spatial or temporal knowledge gaps. And I can speak a lot more to some of those observations and partnering with Indigenous communities, but maybe I'll just leave it there and we can pick it up on questions.
Thank you very much. Great. So next, I'd like to ask the same for Carl Goldman in terms of introducing himself and telling us a little bit about the bigger perspective from the Integrated Ocean Observatory Systems. Thank you.
Yeah, thank you. My name is Carl Goldman. I am the director for the US Integrated Ocean Observing System Office, which is in the National Ocean Service part of NOAA, and supposed to be interagency, working across all the federal agencies that gather ocean coastal data and integrate that data for 7 societal mission areas and make it publicly available and make it advance research and answer questions and be applied to meet decision maker needs across the nation. We've got 11 non-federal partners within IUS. So Clarissa's briefing was from SCUS, Southern California, and geographically based, understanding local and regional scale issues and plugging into a nationally consistent network is what we're all about. I can't begin to answer all the questions you might have about Clarissa's amazing work on the sea harm network, but I've been working with her for years, and that's the type of thing we're able to do in this network. That's this federal to non-federal partnership. They're more nimble at the regional scale than some of the federal family, and they push me to advance things, and I work to do that. What you all can do for me is help articulate what the next thing we need to do. What's the next integration challenge? What's the communications gap, like Clarissa was articulating on her briefing, in terms of real-time communications when events are happening that's not functioning. Those types of things are good for me to be aware of and my team to be aware of. And Marine Mammal Commission voicing your concerns and what your needs are at our interagency table, and then one-on-one with my office. Those things are always good to be aware of. And so if you ask me the detailed questions, I might defer, I might do my best, and I'm glad to be here.
Thank you, Carl. And we have 3 questions that have been prepared by the commission staff kindly, which we have up there. And there are three large overarching questions with sub-questions, but basically we are looking to discuss how can we improve our ability to predict and monitor shifts? How can we increase collaborations? And how can we detect effects of shifts and their impact on coastal communities? So I think that's going to keep us busy until noon. But if there's additional questions not contemplated in this general framework, we can definitely address those. So yeah, I'd like to, without too much prescriptiveness, just start with any place there, and perhaps we can start with the commissioners in terms of if there's any question, follow up from either presentations or following up with one of these questions. Sue Moore.
Yes, what a surprise. I must speak up on these ecosystem things. I'm most interested actually in the second question with regard to how do we improve our collaborations and communication. And hello, Donna, I'm looking at you even though you can't see me, but I'm also first wanting to thank all the panelists for your wonderful presentations. It strikes me that we are looking at changes that are happening quickly, but also at the regional and sub-regional scale of things. Clarissa, in her presentation to wrap up, was talking about the animal tracking network and bringing that into regional iOS predictive capabilities. And what I spoke with Carl about during the break, and I just wanted to throw it out, and I'm going to throw it mostly at Kate to begin with, is it strikes me that phenology, regional phenology, is really tracked very well acoustically, and that acoustics and the tracking technologies are complementary to one another, and that local observations from communities along the coast, that those three ways of looking at things might be a good way to begin a conversation, but also to be able to track at a regional scale the kinds of heat signals we're getting and things like that. So from the acoustic perspective, Kate, how would you, knowing what you do, which is encyclopedic, about what's been tagged and also where the recorders are, is there some way that you would approach that and in a stepwise way that perhaps the Alaska Ocean Observing System could take on board? Not a big question, real simple one for you.
Where to start? Actually, Sue, it turns out that through Neil Hammerschlag and the Marine Biodiversity Observing Network program, he started BioTrack, and we've now also started BioSound to try and link these two ideas of tracking animals as well as using acoustics to track. Of course, as you know, when we hear sounds or when we hear animals, we don't know how many there are. We can get a pretty good idea of how far away they are and what they're doing. So you have more broad population scale monitoring versus individual animal monitoring. And I think going from that individual animal to the population scale is where it gets a little tricky. Nevertheless, I showed an example in my very, very fast talk of using acoustic data that has shown us shifts in bowhead whale distribution that show exactly the same thing as the satellite telemetry shifts. And so my postdoc in my lab, Angie Szorka, is actually currently looking at overlaps of ship traffic, noise levels, and bowhead whale core use areas. So that's linking the acoustics, the AIS data, and this is work with Donna as well, and the telemetry data. So that's, I think, a really good example of where that can work. The issue is often where we have recorders is not where the animals necessarily go. But I would say that the bowhead whale studies have, well, and actually with belugas too. And again, this is work that Donna and I have done, comparing changes in phenology acoustically with changes in phenology that have been shown by satellite tag belugas. So those are a couple of examples, but I think they're a pretty unique situation where there's a lot of effort to put tags on animals and use acoustics. Although I expect that with the North Atlantic right whale, this might also be the case, except that we don't put tags on those guys. But we know where they are. So you've got visual observations, acoustic observations, and shifts in the behavior. But then also linking in terms of thinking about the environment and the satellite telemetry idea, certainly the development in a lot of these long-term satellite tags that actually measure oceanographic variables, I think is really driving our science forward. And this is work that Steve Okenen did quite a bit, working with John Sitta. And in John's latest paper, looking at the shifts in distribution of bowhead whales, he actually found that they are feeding at different locations in the water column using the telemetry. And that's not something that we're going to be able to tell with the acoustics, but that wasn't a complete non sequitur.
We have next Dr. Andy Reid.
Yeah, thank you. I also want to thank all the panelists. It's really a great series of presentations this morning. And I'm been thinking a lot about the first question, improving our ability to predict these changes. And I'm going to pick on Sean, I think, because when I think about that, I think, of course, about North Atlantic right whales. And I loved your analogy about the cameras outside Starbucks, right? And all of a sudden nobody's showing up. So maybe if you could just talk a little bit about your thinking about how we can get out ahead of that. And, predicting is not so important with large populations that are not vulnerable, but for critically endangered populations like North Atlantic right whales, we just can't afford another 2017. So yeah, your thoughts on that?
So is this on? Can you hear me?
Yeah.
Okay. So my thoughts are somewhat controversial on this one. But obviously the commission just had a tagging workshop, and I think it's not that I think tagging is the solution, but I think it's an all of the above portfolio. Most of our traditional practices are outside of tagging are essentially presence absence detectors, whether it's acoustics, as Kate made the point, it's where we thought to put receivers or we had resources to put receivers. And it's the same whether it's sending out a ship or sending out a plane, or even where we task satellite time for imaging from space. Every single one of those is where we as humans are making our best guess with our human brain of where these animals might be to invest survey resources. And we've learned so much from all of that. But I think the way we get the animal to tell us where they're going next is telemetry, for better or worse. And it's controversial. We have arguments within the right whale community. Should we tag them? Should we not tag them? I have arguments with the commission about should we put acoustic tags on gray seals? And is these impacts on animals? We're struggling with anthropomorphic opinions on issues, but technologically we have the tools to do it, but we have to sort of balance what are animal welfare discussions and health risks and trade-offs at every level. So I think we could fix a lot of this with telemetry technologies, but at least it would help. I feel like we didn't have the tagging telemetry technology in 2010 when the whales moved, so I don't want to say like, well, if we just tagged them, none of this would have happened, or we would have been at least a few years ahead of knowing where they went to the Gulf of St. Lawrence, right? But if they take off again, right, and we're going to sort of scratch our heads for 3 or 4 years, like, are they coming back, or are they going somewhere else? The fastest way to understand that would be to have a small, I think if you had a dozen or 20 animals with a long-term tag in the population, you'd get hints of where they're going. And the reality is with right whales, people like to think we know where they are, but we know where at any given point, maybe 10% of them are for part of the year. We just have really good supermarket pickups, whether it's, some of them go through the Gulf of St. Lawrence for, 50% of them go through the Gulf of St. Lawrence, but over the course of a summer, they're not all there all the time. They're often somewhere else. And it's the same with Cape Cod Bay and Southern New England and the lack of their presence in Gulf of Maine. And so my concern is very much because I guess my concern is we manage those areas where we know where they are. But I think a lot of the mortality is where we don't know where they are. And we don't have any way of knowing how to manage that. And it's one of our biggest risks and pushbacks from stakeholders is, we had when we first put our most recent rule in place, there was a closure in the Gulf of Maine that was part of it. And a judge shut it down. And the only thing I think that really reopened, this is speculation on a litigation activity, right? But, the judge shut it down. And then a week later, Mark Baumgartner happened to have a glider in the middle of the closure that had a right whale go boop boop. And it was like the judge couldn't argue there aren't whales there. And so, and I think that was a, acoustics, but a telemetry technology, any of these sort of presence absence detectors. We need a portfolio of tools, is not one as a silver bullet.
If I could just throw my opinion here. It seems to me that we have a little bit of a hierarchy of data volume in that with telemetry, especially tag telemetry, we have very few individuals really relative to the population that we can track. We get very good longitudinal data for a few individuals, and then things like satellite imaging that Sean mentioned probably gives us a broader scope. And then when we talk about acoustics, we really have a broader scope as well. And then coastal communities, another observing base, coastal base, or people that are citizen scientists, that kind of thing, we can probably have a much wider scope. So it seems to me that there's a little bit of a funnel there, or a hierarchy that can probably be somewhat optimized or that purpose. Francis, do you have a?
Sure, thanks, Daniel. And again, thank you to all the speakers. I wanted to shift track. Obviously, I got delayed in the coffee shop. You should have had a camera there, Sean. It was packed.
I ordered ahead.
I know. You know about stuff. So Fernando, I wanted to ask you a little about your work. And one of our questions here is about collaborations. And obviously, you're in Mexico, you do most of your work on the rookeries, but your telemetry data showed us your fur seals really coming up and feeding, off California, Oregon, and Washington in US waters where we have fisheries. So from the humpback examples and the right whale examples, these changes in distribution of coming north lead to interactions with fisheries. So I'm wondering if you could just talk a little bit about bycatch of Guadalupe fur seals in the US, how much communication there is between your program and fisheries management in the US, and if there's something there that we should be thinking about or helping with.
Can you hear me? Yeah.
Mm-hmm.
Yeah. Thank you, Francis. That's a very important question, because based on what you are asking and what the colleagues were saying is that certainly this species no frontiers, no borderlines that are placed by humans. In this case, as certainly I was showing you in one of the maps, Guadalupe fur seals really take advantage or have an habitat use in the California current system, and that has led or has allowed us to have these communications with different collaborators in California, yourself, in order to make these programs together. When I talked about this telemetry collaboration with Tenaya Norris from the Marine Mammal Center, everything began in relation with the UME, for example, in where there were some Guadalupe fur seals being stranded on the California coast that were being rescued by the Marine Mammal Center, rehabilitated, and released with a satellite tag. So there was an important question of, okay, these rehabilitated fur seals are doing this based on telemetry. What are they doing in their mother colony in Guadalupe Island, in order to be able to compare those two scenarios? So they brought us together in that very strong collaboration that we are having, and that is opening many doors in there. In fact, you were there in a workshop, in a very good workshop that we made surrounding the Guadalupe fur seal at Laguna Beach last April. We were there talking about collaboration strategies, what is important to do regarding the Guadalupe fur seals in terms of both research and conservation. There were some federal authorities there that was very important from both US and Mexico. So that's like a good example of what can be done for other species that are being shared between countries. And of course, fisheries is a threat for many pinniped species and cetaceans, of course. in fact, there is an article by Kovacs, and it's been maybe 10 years, about the threats that are facing pinnipeds. And one of them, or the first one, kept being fisheries, although climate change was right there. So we have studied that too. For what I was speaking a little while ago about this interaction with fisheries, how it is so important for humpback whales, for California sea lions, because they have a strong inshore coastal habitat use, so they have a strong interaction there. But since, as I was telling you in the presentation, since the water seal is a squid consumer, is an offshore predator, it has a lower interaction with fisheries, although there is interaction with very offshore fisheries, like they're taking advantage of sharks or bill fishes or even squid fisheries. There is also interaction. So it's not in a very high degree, but I think that type of workshop that we had allow us to speak with the right people in order to be in communications when these rare interactions are being recorded in offshore rare fisheries. It's a different scenario than the humpback whale or the Californian sea lion. But it is also something that we need to pay attention to. Yeah.
Thank you, Fernando. Do we have any questions from the Committee of Scientific Advisors? Or from others in the public?
Yes, I was just thinking about the humpback whale problem on the West Coast and the right whale problem on the East Coast. And I've had the impression very crudely that the crab fishermen in California and Oregon, Washington are more amenable to getting involved in fixing the problem. And I don't know if there's a cultural difference or a technological difference or an economic difference, but we've always talked about one side of the continent learning from the other side. So I thought having Sean here and Karen, maybe they could each comment on their perspectives of that, what one could learn from the other or not learn.
Great question, Randy. Thanks for that. On the West Coast, the willingness of fishermen to accept the problem and try to do something about it varies quite a bit. The fishermen that have been involved in the working group processes in the different states have come to accept that, but sometimes they're blacklisted in their own ports because the other fishermen don't. So there's quite a bit of heterogeneity, but at least there are fishermen that are actively willing to work and that have been very engaged in some of the alternative gear processes and that, quote, see the writing on the wall. The other component that I think might be different, and maybe Sean can confirm this, is that most of the crab fishermen on the West Coast are seasonal crab fishermen because it's a very seasonal fishery. And traditionally, they have gone from crab in the winter to salmon in the spring to albacore in the summer, and they're kind of sablefish and a number of other fisheries that they switch to, so their gear gets reconfigured, and that might culturally make them a little bit more willing to accept changes, particularly since the salmon fishery is basically gone, and that was something I didn't mention, but that was actually one part of the perfect storm, is that historically, they didn't fish for crab in the spring because salmon were around and it was far more lucrative, but the salmon have tanked. And so that fishery really has not been existing in any substantive way for quite some time. And so crab is the best opportunity in the spring. But I think the nature of the way they fish in multiple different fisheries, and that the situation was just so overwhelming that, yeah, they're fishing and suddenly these whales, they're really just getting into the gear in a big way that there are enough of them willing to engage that we have made progress. And I will say, talking about collaborations, having at least some of the fishermen engaged, and really thinking it through and talking about the ecosystem with them and sharing what we learned from our scientific studies that they don't understand, and hearing what they see. And when we see the same things expressed in different ways is really powerful for bringing everyone together and helping to foster those collaborations. So I'll stop there and I don't, any of you want to compare, contrast?
Yeah, so I'll sort of, having worked on both coasts and grown up in the East Coast, and I often think about the first time I met Kate. I was about 2 weeks off the sheep farm from New York and, and sailing in the Southern California current. And I brought her, it was a very different cultural adaptation for me to move to the West Coast. And I've watched that difference between both areas my whole career and thought about that a lot. And as I've moved back to the East Coast, it's sort of hit with East Coast culture. So there are cultural differences, but there's an underlying challenge on the East Coast for the fishery, which is this issue of having a hard time accepting the problem is real. And having spent a career in sort of looking for rare events and endangered and protected species things, I can totally understand that perspective, which is, you know, there's 2 million lobster lines in the Gulf of Maine at peak season, and they fish year round, but it's seasonally peaks. You know, and at the peak, there's upwards of 2 million lines out there. I've seen some numbers estimate, but there's 400 right whales. And so from a right whale's perspective, they have essentially a 1 in 3 chance of getting entangled in one of those lines every single year. But from a lobsterman's perspective in the Gulf of Maine, they can go 2 or 3 generations without ever actually being responsible for whale entanglement. You know, right whales are pretty rare to them, so they never see them. And where we really think a lot of the risk is more in the offshore environment where we have heavier gear and rarer events, and you know, and then the gear just may disappear, right? You know, the animals or right whales so strong enough, you know, humpbacks are Ferraris, right whales are D8 cats, right? They hook up a line of lobster trawls, they just bring it along with them, so they might get entangled, but you know, connecting it to the animals don't get anchored by the gear very often, and so it's partly, you know, everyone hates change in New England, but there is that cultural thing, but there's just an observation difference that makes it harder for the stakeholders to really buy into the reality of it. And so, but underlying that, I think we are seeing actually where we are making progress is in similarities. You know, you get people that see the change, see the need for change, start buying into it, and then they become what we've really learned, and me in particular, I have a gear team that works for us at the Northeast Fisheries Science Center, and I learned very on the worst thing I could try and do was explain something to a fisherman. I should have the gear team who are, you know, fishermen working and fishing, them talk to the fishermen. You know, I don't know what it is when the words come out of my mouth, but it just ends up being offensive. So you know, have the right people talk with the fishermen, and then they seem to get it, and then they become their own messengers to each other. The other similarity I noticed from your talk is both fisheries are heavily overcapitalized. You know, trap pot fisheries in the US are essentially territory marking. You know, in nearshore Maine, the average lobster is probably, I've heard a statistic is caught as many as 7 times before it's actually large enough to be harvested. You know, they're fishing with way more gear than they need, but they're marking territory in competition with every other fisherman. It's essentially a race to catch a lobster once it becomes harvestable in New England. So and it sounds like there's a touch of that in the Gulf of Maine or the Dungeness crab fishery too. So, and then speaking that, you know, you can see humpbacks swimming in and around the gear, you know, from shore. It's one of these things. So it's an obvious thing. It's not a deniable. It's not just well, we can get away with denying it, but it's just so in your face obvious that this is real and this is happening. Whereas, you know, we've got, I think 10, maybe 20 in the gear recoveries from right whales in the history of the program, knowing something like 2,000 entanglements have happened, but like 20 where we've been able to track it back to at least a fishery, if not a fisherman. So it's just hard.
If I can just ask a follow-up question, because Randy really set it up well. Sean, you mentioned moving from surgical management areas to regional management areas. And in Karen's presentation, I was surprised to find that a static management tool actually performed better than dynamic, because in the last decade or so, we have been sort of promoting the idea of dynamic spatial management as a really good solution. So I wanted to see if you would have maybe some thoughts on what this future of management and tools for management would look like in both areas, and if there's commonalities or differences.
Yeah, great question. We were all kind of surprised at the result of the simulation, and I'll caveat it by saying it's a simulation. So it's not necessarily the truth. It's something that can help shed light and I think open up conversations around what might be going on. That said, my thoughts on it comes back to the overcapitalization. I think the key factor is that the simulations, the Free et al. Manuscript, those simulations showed that they can basically catch 80 to 90% of the amount of crab with 30 to 50% less gear. And if you implement that across the board, across the entire West Coast, that reduces entanglement risk the most at the lowest cost to the fishery. And so it's not so much that it's the most effective at reducing the risk, but it's the trade-off between the risk. And so that's one factor. The other thing is that the most effective risk reduction measure was actually, if you have entanglements, you shut down the whole fishery for the rest of the year. But obviously that takes away people's livelihoods. The cost was tremendous. And those intermediate ones, the proactive dynamic, or things where you would go out and use opportunistic sighting data and do targeted aerial surveys like we have been doing as part of the California ramp, and use that to inform which zones need to be closed because there are whales there. And I'm going to quote Dick Rosenblatt, an ichthyology professor at Scripps, who used to tell us fish have tails and they sometimes use them. And I think that's ultimately the core problem, is that you may have whales south of a boundary between a zonal management area, but that doesn't mean next Tuesday that they won't be north in the area that just opened and will have all the gear thrown into it at once. And so it comes back to the complexity of managing it in a way that, given time lags, you do your survey, you evaluate the data, you make a management decision. It takes the fishery 2 to 3 weeks to be able to respond either way, bringing gear in or out. By the time you get there, things may have changed. And the California current is so dynamic that they probably will have changed. And so I think that's where the dynamic management approach is, I will say, more challenging. I don't think that a single study, a single simulation is the answer, but I do think it is food for thought, and that it can help us, zoom in on the things like the overcapitalization. And in Oregon, in Washington, where they did have the 33% spring reduction, it had virtually no effect, a very small effect on the total amount of catch. So it is a matter of just pulling out the excess gear that really isn't doing that much. And I think in our case is probably why these analysis and modeling results are coming out the way they are. But I think it is food for thought, and I'm a big fan of playing around with the models, breaking them in different ways and trying a bunch of different assumptions, because sometimes the odd answers are the ones that actually are the most interesting and informative.
So I'd agree with that. I think we tried dynamic management in the Gulf of Maine 20 years ago, and it ended up not working because effectively it was just the way the US fishery system was set up. We were essentially doing a mini rulemaking every time there was a right whale sighting in the middle of the fishery. And then because the fishery is so overcapitalized, you have small boats trying to move 800 traps, and they can only move, some of them 10 to 20 at a time. By the time they could get out in between weather windows and start moving that gear to somewhere else, the whales had come and gone. Like, it just didn't work in the US lobster fishery. The Canadians are working really hard with dynamic management in the Gulf of St. Lawrence, a mixture of dynamic and static management practices. And in this year's sort of mortality report on right whales suggests maybe it's really helping, but dynamic management is really expensive unless you have some sort of remote sensing technology that can be your indicator, right? But if you're relying on planes and boats and those sorts of things, it gets really expensive really fast. And someone asked me, was my last slide just sort of, give up, it's hopeless, right? But it was part of it is to recognize that we humans are everywhere. So we need to be thinking about management solutions that are not us beings absent or present, but coexistence. We really need to be thinking about, okay, how do these organisms survive with us physically cohabitating the same footprint, whatever we do. Because, you know, I often sort of flippantly joke that fishing was like the issue for these animals through now, and it still is an issue, right? But what's coming is our urbanization of the ocean, with offshore wind, other renewable energies, marine aquaculture to meet the protein demands of 10 billion people, and marine carbon capture infrastructure, all of the predictive sort of needs of what those things are going to be in the next 50 years to meet our climate change demands it overwhelms any footprint that commercial fishing has in the ocean. And we need to be thinking about how we're going to sort of move into that space and not be impacting those animals, so that we have spatially resilient solutions for them. So, and that's what I like about ropeless fishing and just large scale speed zones and whatnot. So
Karen, you have a point?
I just wanted to add one component to that, kind of related to the dynamic static and also the collaboration end of things, and which is dynamic management is kind of a scientific and management construct. The fishermen, in my experience, the fishermen I've worked with really have a hard time buying into it because it makes their lives so much more complicated. And if, as an example, for the Dungeness crab fishery, for them to string along every 2 weeks the ramp to say, can we open, can we fish yet, or the whale's gone, they have deckhands they have to hire, they have gear they have to prep, they have to decide, am I going to leave my gear and still fish black cod or something else? And having the dynamic management is a large burden on them. And the question that I think is really important that they have brought to the table is, what is that trade-off? Is it worth it for me to get out a week or two earlier to have all of this uncertainty and maybe lose my good deckhand and have to hire this crappy guy? Or, there's lots of little components to that. And the challenge that we've seen on the West Coast is that varies up in north, south on the coast. The Central California fishermen have a very different way of operating and depend on the Thanksgiving market in a way that the northern ones don't. And so they would come to completely different conclusions about what dynamic management works and what doesn't. And so I think as we're thinking about solutions for these, I am a huge fan, even though it is initially very difficult to have to start those conversations with fishermen that just say, we don't have a problem. As you said, I've never caught a whale. I don't have a problem. They absolutely need to be part of that conversation to figure out what works, because if the dynamic thing doesn't work for them, then it's not going to work for anybody really.
Okay, so we're going to have Sean respond,
I was
and
going to pivot a comment
okay.
to Carl.
Okay.
So one of the opportunities with ropeless fishing is right now the Maine lobster fishery it's a very secretive fishery, and everyone's got their turf. No one wants each other to know. But in about 10 years, as we transition to ropeless being common, it's going to become a big data fishery. I mean, right now, already we're sort of in the process of transitioning the concept of ropeless technology. It's going to be a whale conservation measure, but it's really just going to change how the entire fishery operates. When you suddenly have the ability to sort of have automatic recording of catch per unit effort for every single trawl out there as part of a big data space, all of that's going to move into a different way in which we're going to prosecute these fisheries to harvest animals. And those are going to turn into the fishermen they're businessmen. And once they see the big data opportunity, rather than sort of, using my daddy used to fish over here sort of mindset, they're going to adapt very quickly. Every time we give them data that they can use to improve their harvest, they adapt very quickly. And I think once that becomes, those sorts of data become available in the fishery, we'll see a very big change in strategy and how they approach this. So I don't know if you comment on that or. Okay.
So I'm going to ask Robert Sweedam here for his question. And I know, Fernando, you have a question as well, or a follow-up. So maybe we can just pivot off each other. So yeah, Robert.
Robert Sweedam on the Committee of Scientific Advisors. And I wanted to follow up or make a comment first you asked a question about incorporating local knowledge, my interpretation. Can that help us better understand the shifting distributions that are occurring? And from my experiences in Alaska, that including Native people, indigenous knowledge, and local knowledge, and this probably applies to fisheries everywhere too, is it including information from the people that are on the water the most is going to help all of us improve our understanding of how distributions of marine mammals are shifting. And so, you know, Karen, your comments about including fishermen in the conversations, I think that all agencies should try to do that. And that's happening, whether it's for Native people in Alaska or whether it's fishermen, that's happening, but I think it can happen better. And so I think we all could benefit by trying to include that. My question is really about something that Kate said. She was talking about the shift of marine mammals in Alaska and how at St. Lawrence Island, that bowheads and walruses are becoming harder to hunt, and for those communities to maintain their food security, their food sovereignty. And one of the characteristics of Inuit culture is that people are really good about adjusting their behavior to changing situations. And so I agree with you completely that culturally, folks in Alaska, Native people in Alaska are going to be able to shift in terms of what marine mammals they might use to feed their community. But my question is are the management systems, do they have that same flexibility in allowing indigenous people to have that same flexibility as the Inuit cultures do? Maybe that's not a question for Kate.
I was gonna say, is that a question for Kate, or do we have Donna?
Yeah, thanks, Robert. Good to see you. So I think that's a really, I kind of want to comment on a few things you mentioned. So I was talking about the project that I lead, the Alaska Arctic Observatory and Knowledge Hub. And so I think that there's some really interesting, useful things in partnering with folks in coastal communities and indigenous knowledge holders. In the AOK project, we have over 10,000 observations that have been made by coastal Alaska Native observers since 2007 in some of the communities. And I would argue that these are pretty underutilized for management and conservation purposes. So just in terms of like some of the themes that have come out of these observations, I mean, certainly they're documenting environmental changes like sea ice loss, warmer air and ocean temperature, but also the local scale impacts to subsistence calendars, their marine mammal harvest, access and availability, as you were talking about, the decreased safety they're experiencing when they're conducting these traditional harvests from the sea and on the ice. And so I think one of the opportunities is to value some of this indigenous knowledge and perspectives at the same level and validity as the Western science data. So increasingly through things like indigenous-led Alaska Native co-management organizations, we can have an improved ability to track these changes, but also weave these indigenous perspectives with scientific data that can then be used for more ethical and equitable co-management. So hopefully in sort of providing that pivot, so where we can, if we can value that indigenous knowledge at the same level, there might be opportunities to complement indigenous knowledge and observations with scientific research that can enhance our understanding of the changes that are being observed, promote more holistic approaches to observing and management, and then co-identify strategies for adaptation, which could be rooted in some of those local priorities.
Fernando?
Yeah, I think that last question was very important because it was also related to something I wanted to say a few minutes ago. I think I all agree about the finding of solutions regarding this problem with whales entanglement processes and others. I think it may not so much the case, of course, for the right whale in of course the problem with the communities in the north, but other cetaceans like the gray whale, the humpback whale, that again, as I said before, the species know no borderlines, and I agree that these simulations and this analysis surrounding the crab fisheries, etc., are very important, and to try to find solutions and to buffer this problem. But it is the case of these communities in the north in Alaska, you were asking how flexible they could be. They also got entangled in Mexico a lot, especially humpback whales. So as I was speaking with Karen a while ago, they are more entangled in fishery gears like gill nets and stuff like that. And it's very interesting because I was telling her how sometimes we have had entangled whales that are carrying or dragging fishing gears from the north, from Alaska, from Canada. So it is really a dynamic management, but I think it should be put on the table that is really complex because it involves the whole distribution, the whole habitat use distribution of all these whales that can travel for thousands of kilometers and are going to entangle on their way. And in our case in Mexico, and Francis will not let me lie, to work with fisheries in Mexico, for example, the case of the vaquita, is not easy. There is no flexibility there. And not only in the upper Gulf, in the Gulf of California, where we also have strand entanglement of whales, also in the Pacific, in the Baja Pacific area, there are also a lot of communities there, and they are not flexible. They have been harmed by the government for decades, so they are not friends of the government. There are also dark scenarios surrounding the fisheries in Mexico. So it is a very holistic, very integrative, but it's something that should be taken in consideration for this long dispersal species.
Thank you. And I wanted to turn this to Carl. I'll give you a heads up. And it relates to the idea that we have underutilized information from local coastal indigenous communities, as Donna was mentioning, and the large volume of observations that they have. And I think we're seeing that the rise of that and citizen science and so forth around the world, at least in some areas. And I wanted to ask, to what extent does IUS anticipate or is able to ingest that kind of data in a way that can be interpreted, whether raw observations or the other thing is that, as I was mentioning earlier, there is a little bit of a data hierarchy in terms of volume. And we now have the data tools, the data analysis, statistical tools to integrate all those data sets and account for uncertainties and so forth in a way that we can generate integrated models, predictions that take into account all the various different sources of data. So to what extent can I use or is already engaging in that kind of effort where, because my sense is that a lot of the data that comes through channels like IUS and so forth are very official in that, they come from satellite observations, buoys, things like that, right? So yeah, maybe you have some thoughts on that.
Yeah, well, one of our specialties is understanding as best we can through stakeholder engagement on the ground in the communities at the local and regional level, what needs are, and yet we don't have as much engagement resources as we would like. So it's a little bit ad hoc in terms of each of the regions has some of that capability and they're employing boots on the ground, if you will, to understand. It's folks like Donna who probably know the answer to this question certainly better than I do. So I'd maybe want to kick it to her in a minute. We have to use FAIR principles in terms of data to make it available publicly, but you need to use CARE principles as well when working with communities with indigenous rights and knowledge. And we've had some technical capabilities to do masking, if you will, of point data for subsistence harvesting, where you put it into a hexagon and you get permissions to do that so that you can look at trends on a broader scale and not give away specific fishing locations of an individual, for instance. And so we have spotty instances of success at that type of thing. I don't know how well we're doing, and I would need to ask my regional experts actually on scaling that. And we've got funding for coastal resilience related work within the Inflation Reduction Act, and we're pushing to look at underserved and overburdened communities. And my regional practitioners are asking, what do you mean by that? How do we do that? And we're saying, we need to work with folks like Donna, who are expert at this, to do this at the speed of trust is the way that you move things forward. So it's not something you can do just haphazardly. Across all of NOAA, all of our regional and coastal programs have been talking about the challenge of stakeholder fatigue, where you have a good partner who's able to talk to scientists and experts, and 27 scientists want to come talk to them. It's not sustainable for them. And so in the recent successes, we've got Alaska, Pacific Northwest Nanus, and Hawaiian Islands Pacayus doing a backyard buoys project with SOFAR buoys, where they're taking them to communities and letting them select where they're going to deploy them. And it's helping in places where there's more open water days to understand go, no go decisions for the local fisheries. It's also empowering those communities to understand that the technology can be for them and not just taking from their area. So that's a pretty broad answer, but I think Donna probably has maybe a few flavors of adding to that, if you let me kick it to her. That
was great. Thank you, Carl. So Donna, do you have anything to add there?
Sure, a couple things. So first, just on the collaborations with AUS, I mean, the Alaska Ocean Observing System, we are partnering with them in a few ways and kicking them some ideas also under the IRA funding opportunities. But so it has been really important to sustain some of our ongoing partnerships with people in communities. So for example, in Utqiagvik, or formerly Barrow, Alaska, the AOK project in collaboration with others has been mapping the trails that whalers build on the sea ice every spring. And so when I say build trails, right, like until you experience it, you don't really understand how dynamic this landfast sea ice is and how jumbled up it can be. I mean, ice that's 10 feet tall, and they're literally out there with pickaxes. The whalers are out there with pickaxes, building a trail that they can drive their snow machines to reach the ice edge, the flow edge, where they do their whaling. And so we've been working, and AOS is helping coordinate now with that. We've been working for the last over 2 decades, I think, measuring the sea ice thickness and mapping those trails in partnership with the Barrow Whaling Captains Association and others in Barrow. So that's just like an example. Otherwise, I'll just sort of pivot and also talk a little bit about sort of the data principles, at least within the AOK project. We recently met with all of our Inupiat observers to ask a couple of questions. One is, who do you want to be using your observations? And then also, should we put some restrictions? What kinds of restrictions should we put on access to the data? In general, folks really are interested in, I mean, I think that there's a recognition that, these are Indigenous perspectives, often Indigenous knowledge shared through the tracking of environmental monitoring, and they want their observations to be used. Management and agencies have been identified as one of the organizations that they'd really like to be using their data, their observations, co-management, Alaska Native co-management organizations. But also they expressed a little bit of concern with management agencies. And I think that goes sort of with the history of how Alaska Native Indigenous knowledge has been used in the past in management arenas. And so what I see is like the opportunity for building relationships, and that there are people that are really ready and want to partner. They need a seat at the table.
Thank you, Donna. Next, I would like to ask Vera Metcalf if you could share your views with us on this topic.
Thank you. Hi, everyone. I'm Vera Metcalf. I serve on the commission as a special advisor on Native Affairs, and it was a challenge to get here from Nome, Alaska, where we left a blizzard and heavy snow in Anchorage. But I wanted to comment on what Kate said and to Robert's comment. The shifting of the marine mammals in the Arctic is concerning, which leads to food insecurity for many of our communities. St. Lawrence Island is my home. Little Diomede, all those communities rely heavily on marine mammals. 80% of our diet comes from these resources. And I also am a big proponent of indigenous knowledge. I sincerely agree with Donna, hi Donna, on her project, which is similar to what we do with Sea Ice and Walrus Outlook, working with some communities in the Bering Strait region on sea ice observations and other information from our observers. But I wanted to comment also that yes, to indigenous knowledge, which leads to co-production of knowledge, which is another resource that I heavily advocate for. And observers in our communities are always the first to see so many changes. And with that, I think it would be good to increase the collaboration, but also to make sure that compensation is included in the work that we all are trying to do. Many of our communities now have Starlink, which has been has increased better internet connections. So, you know, it used to be very challenging in the past, but thanks to Starlink, you can bring your own little dish to a camp somewhere and you could still communicate with your people in the communities or somewhere. So co-production of knowledge, indigenous knowledge, I highly recommend, but also adequate compensation for our own people.
Thank you.
I'd like to follow up on that a little bit,
Sure.
Daniel, and thank you, Vera. And this is the idea that we need to value other people's time and knowledge the way we value ours. Like, we don't expect to come here and not earn our salary and be paid to come to this meeting. Well, some of us might, but people providing their information, their experience, their knowledge is worth something. And whether it's a gas card or an honoraria, we need to understand that that makes sense. And we've got to consider compensating people for their time and their knowledge, because otherwise we wouldn't have it. And something that Robert started, and he might be able to speak more eloquently to this, is at least up in Utqiagvik, and I know one is happening this week in Tikigaq and Point Hope, are traditional knowledge panels where the North Slope boroughs started to bring scientists in with whalers and hunters and say, here's our idea for what we think is the science we want to do. Is this valuable to you? What do you want to learn? And how can we help co-produce this knowledge? So how can we as scientists not drive what we think are scientific questions down your throat or bring them to your communities? We want to know what is valuable to you and what science do you want to know? And how do you think that could happen best? Because people who live in communities know the environment best, they know the weather best, they know the currents best, they know the animals best. So we can't assume that we can just parachute in and do our science. It's much better, much more integrative and much more interdisciplinary if it is a co-production. So thank you, Vera.
Robert, do you have any other thoughts on that?
Yeah, thanks for all these comments. I think they're really useful and helpful. And Kate, I think you articulated it really well. But Carl, I think I really like how you said it too, that, and I'm not going to get it quite right, but I think you said that the speed and the trust and relationships really drives everything else. And so in the decades that I spent on the North Slope, that the relationship that scientists have or managers have with Native people hugely influences communication in a positive way, hugely influences in a positive way implementation of management actions, and it becomes a shared situation instead of somebody imposing their will on somebody else. And that's true whether it's for collecting science or doing management. And so all of those comments are helpful, and relationships are trusted relationships are the key.
Thank you, Robert. Do we have more questions from the audience? Yeah, Peter.
I pull that string a little bit more just
Oh,
to say one of the fears I have that I was talking to Andy about is Inflation Reduction Act funding is one-time funding right now. And so we want better behavior from our communities in doing stakeholder engagement. NOAA has a service delivery framework we've agreed to, which would deploy an ongoing engagement to do co-development. And we want to do that, but that requires culture change so that you don't send 27 people to ask the question and you learn 27 things and you have permission to bring those back and translate those into requirements and share them across the agency's line offices. So that's behavior we need to change. And then, so the one-time funding is a thing where the relationships need to be built, and it's a risk if you can't keep the staff that are being hired to do that engagement. And so that's a concern of mine that I just wanted to acknowledge is part of this puzzle that's hard to put together.
Yeah, and if I may, sorry, Peter, I didn't mean, I've been trying to wait for a strategic time, but I just wanted to add that to me, this conversation is so incredibly important. And, the co-development of data, I haven't heard that term. I don't work with the indigenous communities, but in our fishermen, and having indigenous knowledge or local community knowledge, traditional knowledge as part of IUs, I think one thing that I would really like to encourage based on my experience with the Dungeness crab fishery is to not view them necessarily as independent data streams coming to conclusions, but to maybe IUs can help put them together. Some of the most powerful moments I've had have been taking the fishermen up on a plane with me to do surveys, and they can see our perspective. And the fisherman looks down and he goes, "Oh yeah, there's the 40 fathom curve." And I'm like, "How can you see the 40 fathom curve from the air?" He knows the area, he knows what he's seeing, and integrating, having him see what we see. And then sometimes he would come and call me and say, "Hey, I was out today and I saw this, and what do you make of it?" And finding the overlap, the synergy, the commonalities, that builds that trust. And I love that phrase that progress works at the speed of trust, because that's really what's been so important. And so I just wanted to add that in because I think that fits in this theme, and looking with ways to interact and share the data, the knowledge, the experience, and look for commonalities or where we're seeing different things. Try and think about it being a common question that we want to tackle with both of our sets of tools and knowledge. So I just wanted to get that in there. I just love the conversation that's happening.
Peter, thank you kindly for waiting. It looks like Donna has some perspectives here as well that we'd like to hear.
Yeah, sorry, Peter. I just wanted to add on that. Based on some experiences, I really appreciate this conversation around co-production of knowledge. In Kotzebue Sound in Northwest Alaska, we had a project where we brought an interdisciplinary team of scientists and collaborated with the native village of Kotzebue, who specifically identified an elder advisory panel. And so through about 4-year process, we collaboratively identified a set of research questions about sea ice loss in the region. Not surprisingly, a lot of the research questions, I think half of them related to marine mammals, because they are so integral to the way of life for folks in Kotzebue. But what I wanted to point out, that was, I think, one of the things that was really important to that project was, whether there's a few different names for it, but like a local facilitator or a boundary spanner is another term that's been thrown out there. So somebody who's in the community who can translate and help to build those relationships between scientists and indigenous knowledge holders, who has that local perspective. You see it also in the North Slope Borough Department of Wildlife Management. There are local partners who have some scientific background, but also like cultural competency to go back and forth between those worlds and really help facilitate the success of projects like that are trying to achieve co-production of knowledge. Just wanted to add that in.
Thank you, Donna. Peter, and then Fernando.
Yeah, I really appreciate this discussion of bringing knowledge in, and I wanted to turn a little bit to bringing knowledge out, because one of the things, Carl, that we would say about the ocean observing is it's all big data on oceanographic processes and sea surface temperature, but there are instances, and the example that strikes to mind is the increasing northward movement of HABs, harmful algal blooms, from the Bering Sea to the Chukchi Sea, and all the questions that brings for the communities. So that information comes in and people are asking, how do we find out about this, the implications of this? How do these, and it's a case where larger scale processes are happening that are measured not totally by indigenous knowledge, maybe by satellites and everything else. So how do you get that type of satellite stuff back to the communities? Just a sort of opposite challenge. And I don't expect you to have the answer.
Yeah, I mean, that's a good question. And that's one of the things that we have to sort out. And it's one of the amazing things is the explosion of technologies that enable us to do things. And the next frontier is bringing in edge computing and figuring out the level of edge compute that you need at the sensor location to get a piece of information that's actionable back. And so what level of PAM, passive acoustic monitoring data to process where, so that you get a presence absence signal fastest, and you're not having to send back reams of terabytes of data and then have someone sit in a room and analyze it, but you're actually getting the buoy to do the analysis. And so that type of technology frontier, then get back to, and who needs the information? How are you getting it to them in a timely way for them? And so in American Samoa, the PAC-IU's partners that they have really good engagement with, you know, they're like, we can't get internet. So they created a push message through email, and that's the way that they can get the wave data and that they care about, that matters. So it's that service delivery piece I talked about before is an ongoing engagement so that you understand co-development of what the needs are and the products are that are going to translate the information.
If I can just throw one thing in there, because I think marries really well what Carl just said about the explosion in technology and pushing data back to the user. It occurs to me that I don't know how many people here are familiar with Windy, which is a platform for weather forecasting. It has all kinds of layers of information there that is available on your phone with extreme sophistication. I mean, the amount of sophistication and layers, and yet is widely embraced by the general public because it has that ability to come across and become useful. So as Vera was saying, also with the availability of Starlink these days, for example, it occurs to me that that kind of approach, obviously on a much more massive scale, because everybody wants to know the weather, right? But something like that, it seems to me that we at least have the tools and the technologies is there to also push things back to the local communities. We have 4 minutes left for the session, and we do have Andy. Oh, Jason, thank you. Sorry.
That's okay. I'm Jason Baker, member of the Committee of Scientific Advisors, and it's just an observation, and anyone can comment on it, but most of the species and circumstances we've been talking about this morning tend to be fairly coastal, pretty observable species, and while Fernando's seals are pelagic in a lot of ways, they come to a place where they're accessible and they can be tracked. But of course, there's a huge number of populations of marine mammals that exist in places that are not coastal observations, they're not accessible, and the kinds of distribution changes that we're seeing for these species could be or probably are happening for these others, but we don't have the observational capacity to see that. So maybe commenting on the first question with a focus on how do we monitor shifts in these distributions would be useful at this with our last minute.
We have 2.5 minutes actually, Fernando, and anybody else, please? Kate, yes, great.
Yes, and it's related to what I wanted to say. Yes, and I think the key is having contact with different sectors of the community. You mentioned our fur seals. The reason we knew about the new Guadalupe fur seal rocker, not colony, excuse me, in the Gulf of California, Las Animas, was because of the people, was citizen science. They sent us pictures saying, what kind of sea lion is this? It's weird. It was they were with clients and diving, and we knew because of them. So I think it's important to bring together these different groups. Remind me of a situation in La Paz, where I come from in Mexico, when they established the National Park of Espiritu Santo, which is an area there. The stakeholders brought together fishermen, people from the local community, researchers, people that work in tourism, in order to better create this polygon around these islands near La Paz, so they could make the better decisions. So I think at the end, this large communication is going to help us understand much of what is going on with not only the ice species, but also the tropical temperate species, like the ones we have in Mexico, that it is becoming more tropical as years go by. And that's why Guadalupe fruit seals may eventually take over the Channel Islands more than Guadalupe Island. We don't know that. We cannot discard that. So the only way is collaborators, but also bringing people from different origins. That's going to be key. Thank you.
And in our last minute, Kate is going to close with a brilliant intervention.
No, Jason,
Sure.
I think one way we are listening to distribution shifts is by using passive acoustics. And these are things that you can have not only fixed moorings out in the middle of nowhere, but also mobile platforms like gliders or even floats. And a lot of and Jen Davis with Northeast Fisheries has been doing this a lot, looking at broad scale distribution shifts, just using passive acoustics from these big acoustic arrays where people contribute their data. They're not designed, but I think we can listen in the deep ocean, and certainly the Navy's been doing that for decades. And then we get somebody really clever like Aaron, and maybe we can figure out how to track individuals on either single sensors or multiple sensors. And then we can do that. So I think that's perfectly tractable.
Well, time's up. I see up there. I think people need a break for lunch. Thank you to the wonderful panelists. That's fantastic session. You guys made my job real easy. So thank you very much.
I know.
I was waiting.
No,